In today's lesson, we are going to talk about cookies. No matter how I travel around different companies, I always see bad practices, bad usage of cookies. Although it's kind of a trivial topic for web developers, I see a lot of bad practices in cookies. And cookies are very important, right? They're an important aspect in, for example, security and session and analytics, tracking our users. And everybody knows the basic of cookies, but nobody actually drilled down on the advanced topics of cookies while focusing on the best practices. And this is what I want to do in today's lesson. I want to focus on the best practices using cookies. We will use Express, although even if you don't know, if you're not familiar with Express, the code we'll write will be very simple and understandable while focusing on actual cookies and not the technology on Express. So even if you're not familiar with Node.js and Express, you should see this this lesson because we will focus on cookies, advanced topics in cookies that you might not be familiar while focusing on best practices. We will start with something basic, but we will advance very fast to advanced topics about cookies. So this is a must lesson for any web developer. You have to understand cookies thoroughly and use them while focusing on the best practices of using cookies. So here are the topics that we will cover in this lesson. We will start by starting with a basic. So we're going to start by explaining what is cookie, doing the regular hello world, setting your first cookie. And if you are experienced with cookie, I recommend you skip the basic part and just jump ahead to the more advanced stuff that we will talk about. But we have to start with something. So we have to start with the basic explanation of what is cookie. And we will learn how to handle cookies in Express. So we will work with Express, like I said, but if you don't want to focus on technology, that's okay as well. If you do want to focus on Express, we recommend on writing the code along with the video. So we're going to talk about handling cookie with Express, which is setting the Express using the response object cookie function and using cookie-parser, etc. After that, we will start talking about more advanced feature and best practices. But before we talk about best practices, we have to understand the cookie flags. When you set up a cookie, you can set option flags to that cookie, like security, expires, httpOnly, etc. Those cookie flags are essential to understand in order to perform best practices with cookies. If you do not understand them, then you might set the wrong cookie flag, and then you might have bad practice, security problems, etc. So we have to talk about the cookie flags in order to focus later on best practices. We'll talk about something that browsers are using, third-party cookies, and it's pretty much going to be deprecated in the near future. So we're going to talk about how cookies might use to track user and track the user, which sites the user navigates to. We're going to talk about tracking, privacy laws, GDPR, and third-party cookies. And later on, we're going to focus on more advanced stuff. Cookies is often used as a mean to persist authentication. So after the user logs in, I want to keep the user logged in and do not want to force the user to log in with every request. So I usually keep an authentication cookie. That might be a cookie that holds the session ID. That might be a cookie that holds a JWT token or some sort of secret token. So we will talk about those authentication cookies. Those are critical to keep them as secure as possible, following the best practices. So keeping your cookie secure flag and httpOnly and sameSite, and understanding those practices while using authentication cookie. And if regarding those authentication cookie, popular form of attack that we have to understand is something that is called CSRF attack, cross-site request forgery, where hackers take advantage of the authentication cookie to make a request on behalf of a user. So it's really important that we understand this popular attack regarding those authentication cookies. So we will focus also on advanced stuff, security, best practices. So it's really important, even if you're familiar with cookies, just skip up maybe the basic cookie settings and the basic cookie explanation and jump on to the more advanced. But this is a must lesson for every web developer to understand the best practices in using cookies. Before we start writing code, I need to set up our playground. Now, usually we are running things on localhost. But in this lesson, since I want to cover cookie features that might require secure, true, or same site, I want to run things a bit differently. And I'm only doing this for in my computer for this lesson. You don't have to set up the same playground. You can run things on localhost on your terminal if you're following along and writing the code. Just run things on localhost. That's fine. But for my examples that I show here, I have to run things while mimicking real website behavior. So localhost won't be enough. So what I'm going to do, usually we're running Express apps on localhost. In my example, I want to it's not going to be good enough for this lesson, and I want to run things like a real website. So I want to mimic real website behavior. What does it mean? I want to run things instead of HTTP like we're usually running. I want to run my website with a secure connection using HTTPS with a valid certificate. Cookie has a flag called secure, and a lot of the time I want to turn on this cookie flag, and I want to show you those examples, so I have to have a secure TLS connection. Another things that I need to mimic domains. So I don't want to run on localhost, I want an actual domain. So I want, we're gonna use two domains, hello.com and evil.com, that will map to our local host. And the way we will do this, we will run a reverse proxy. We will run Nginx to map two domains, hello.com and evil.com, to our local host running on 3000 and running on 3001. And what I'm going to do, and I'm going to use Docker to run Nginx. And my Nginx will be configured for hello.com to map to localhost 3000 and for evil.com to map to localhost 3001. And I'm going to use those domains in my example to map to my running Express apps. So to quickly go over the playground that I set up in my computer. So the first thing that I did, I modified my host file. So my host file in Mac and Linux is located in etc hosts. So I modified this file, and what this file does, it can map a domain. For example, in this file I'm mapping the domain hello.com to my localhost, and I'm mapping in this file evil.com to my localhost. So I modified the host file to map domains to localhost, the hello.com and evil.com to localhost. This is one step I did. Another step I did is I set up Nginx using Docker. So I created a Docker file, and in this Docker file I inherited from the Nginx Docker image, and I placed a file called default configuration with my configuration file, as well as a self-signed certificate and a self-signed certificate and key using OpenSSL. Now, the default configuration that I place in Nginx, let's print the default configuration, basically defines two servers. One server for hello.com. That server is listened for 443 for a secure connection using the self-signed certificates that I created, and hello.com will map to our local host running on 3000. And I did the same for the second server using our self-signed certificate, but this time running mapping evil.com to our local host running on 3001. So this is the Nginx configuration, and to run my Nginx, I'm simply gonna do docker run add host. The add host will connect my running Docker container to my host network. My host network is running on the iNet 10.0.0.1, and you have full explanation if you want to set up this playground and see the app running on actual domains. This is also good for development. Some development team want to run their app not on localhost, but they want to modify the host file and create a self-signed certificate so the developers can actually run on an environment running a secure connection with a domain. So some development team actually use this trick to run their app not on localhost. So if you want the full explanation of setting up this playground, you have it in the article below. So to run our Nginx, I'm simply going to do this docker run command. This will run the Nginx that I set up, I already did a Docker build before, so I'm just gonna need to do a Docker run. Now let's check that our playground is running by creating a simple Express app to run on localhost 3000 and checking if our domain hello.com map to our Express app. So what I'm going to do is I'm gonna create a directory called cookies tutorial, and I'm gonna cd to this directory. And what I'm going to do is I'm going to I want to use Express, so I'm going to do npm init yes to create a package JSON file and to be able to install packages to this cookies tutorial folder. And then I'm going to npm install Express to install Express, and I'm going to open this folder with VS Code using code dot. Now I'm going to create a simple Express app running on port 3000 in order to check our playground. So I'm going to create a new file. I'm going to name that file check playground.mjs, and now I'm going to create an Express app. So what we're going to do is we're going to set up a simple hello world Express app to check that it can also be accessed from from HTTPS. It's important is that we have secure connection hello.com that will map to this Express app. So I'm going to import the function we have in Express to create a new application. So I'm going to import create application, and I'm going to use it to create a new Express application. Now that application is going to listen on port 3000, and since we are exposing it to the network to be able to be accessed from Nginx, we will add a zero host to be accessed from the Nginx network as well. And we are going to run function. This function will run when the port is open, just so we can be aware that our app is running. We are now running on port 3000. Great. And we are going to create a simple get for the root path, and we're going to send an hello world. So we are going to getting in our function a request response object, and we are going to send a response.send hello world. Okay, this is our simple Express app. Now I want to make sure that I can access this app with hello.com with a secure connection. So let's start by running our app. I'm going to open the terminal and type node check playground.mjs. Our app is running on port 3000. I can actually verify that my app is running by going to localhost 3000, and I should see hello world. Now let's see that I can also access this app by running https hello.com. And we see hello world. We also see a secure connection. So we have hello world. So our app is mapped, and we also have a secure HTTPS connection with a valid certificate. Now I can actually inspect features of the cookies that requires a domain and requires a secure connection. We set up our playground, and now we're ready to write some code. But before we write code, I want to talk a bit about theory. Explain what is cookies, what are cookies. And before we talk about what are cookies, we have to first understand why we need those cookies, why those invention of cookies was created. And the reason cookies were created is the most popular protocol we're using is HTTP, and HTTP is stateless. So the popular protocol application layer protocol we're using in the web is the HTTP protocol. The HTTP protocol, you probably know this. And by the way, if you feel like you're an advanced user and you know about cookies, you can skip this part about what is cookie. You probably already know it, so feel free to skip this part. The advanced stuff are more ahead, but I have to touch a bit about theory. So in the HTTP protocol, basically our browser sends requests to a server, and the server is responding with a response, sending the response back to our browser. So we're sending a request and getting back a response. Now the request our browser is sending to the web server contains headers, a domain, a path, a body, and the response we're getting back contains status, headers, body, etc. And basically the HTTP protocol is stateless. And what do we mean when we are saying that something is stateless? When we're saying something is stateless, what we mean is that it only is considering the present. It doesn't look on the past. This means that the HTTP protocol, each request is individual. It doesn't look at the past request. And the basic HTTP protocol is stateless. Now let's see it with a diagram. What do I mean when I say the HTTP protocol is stateless? So on the left side, we have our browser. Our browser in the HTTP protocol is initiating a request. You see request A, and is initiating a request sent to our server on the right side, represented by the cloud on the right side. So our browser is sending a request to a server, and in the HTTP protocol, when the server gets a request, it sends back to the browser a response. Now, this is the first request, request A. My browser is then sending another request, request B. So my browser is sending two requests to a server. Now, when I mean stateless, the server only looks at the present, meaning that the server doesn't know that the second request I sent was originated from the same browser. So my browser sent two requests and the server is stateless. It doesn't know that the second request was sent from the same browser. And this is the basic HTTP protocol. Now, this is a problem. Stateless is something that we do require state in our web applications. For example, if you log into your web application, you want the second request to be authenticated. You don't want the user to log in every request he's creating. So you want some persistency. You want the request to be connected. You want a session, a cookie, something that's connected. Your server will know that the second request is originated from the same browser. So for this, to solve the stateless problem, what we can do, how the question is, how can we use a stateless protocol like HTTP and still maintain state and still be aware, our server be aware that the request is originated from the same source? So what we can do, on the first request that we're getting, we can place an identifier. We can send back an identifier to the browser, and we can tell the browser, please send this identifier in every subsequent request. Send this identifier so I know this is you. And what we can do to solve the stateless is use that identifier. So when the server sees a request for the first time, you will send my browser that identifier, and then on the second request, and then on the subsequent request, the browser will send that identifier, and then my server will get that identifier, and it will know that it originated from the same browser. So looking at what I said in a diagram, again, my browser on the left side is sending a request A to my server. This time, my server doesn't see an identifier on the request. So my server guesses that this is a new user that comes to my site. Then my server, what it does, it's sending a response back, but it also sends an identifier or a set cookie header. It sends an identifier in the response and tells to the browser, please send that identifier. Every subsequent request you're sending, send that identifier that I know, so I know it is you. So I'm sending a request A, and my server responds with an identifier. Now when the browser sees the request, now when my browser sends another request to the same cloud, he will send the second request with that identifier. And then my server, getting in the second request the identifier, can recognize that the request was originated from the same browser that sent request A. So this is basically how we can use HTTP, which is stateless, and transform the statelessness of HTTP to be stateful. So a cookie is something to solve that problem, is something that we use as that marker on our request. So what is a cookie? Basically, a cookie is a header. Okay, so a cookie is a header on we're sending on the request. When the browser is sending a request, we set the request as header, and a cookie is simply a header. Now, what's special about this header, that the browser gives this header a special meaning. So the meaning is that the browser stores the cookies for for domains or for a certain condition. It stores cookies, and then the browser automatically sends that header on some condition, meaning that the cookie header is something that the browser sends automatically. It's not something that you need to specify when you send a request. The browser will automatically send the cookies when certain condition happens. So and that cookie can be set by client, by JavaScript, using document.cookie API, or those cookies can be set by our cloud, by our server, using a header called setCookie. So we'll cover those things we'll do a small example demonstrating those aspects. But basically, a cookie can be set by either client running JavaScript or by your server. And what we can do is we can use that cookie as a marker, because we know that the browser will automatically send that cookie on every subsequent request. Then we can store in our cookies some data that we want to persist, and the browser will automatically send that data on every request. So for example, if the user logged in, I can place an authentication token and send it in a cookie. And then every time I get that authentication token, I know that the user already logged in. I can place tracking. I can use Google Analytics. So I can place data that I know that always will be sent by the browser. And by doing so, I take statelessness from HTTP protocol and transform it to stateful. And what we'll do next, we'll start like every other cookie lesson, we'll start by an hello world example. So we'll use Express to set up a basic cookie. So our server will set a cookie on the client, and we will see that the client will send that cookie on after we set it, it will send it on every subsequent request. It will send that cookie automatically. So we will use Express to store an hello world cookie, and that hello world will examine that it's sent on every upcoming request. So let's go back to our IDE and experiment with the cookie by setting a simple hello world cookie. So go back to your IDE. If your Check Playground app is running like mine is from when we created the Check Playground Express app, then go to the terminal, Control-C to close it. Now let's create a new Express application that sets a cookie. We'll create a new file. We'll name that file hello world cookie.mjs. Now in this file, we're going to copy paste what we did in the Check Playground, because in the Check Playground, we already create a basic Express app. So what we're going to do is copy the Check Playground, and what we'll do in the hello world cookie is what we'll do here. We'll set up a simple hello world Express app that will set up a simple hello world cookie. Okay, so we created an Express application. We created a new Express application. We added a route, a get to the root path, and we're getting a request and response object, and we're sending an hello world, and we're taking our Express app and we are starting our server by calling listen. We are listening on port 3000, and when my server is running, it will run this function which will print we are now running on port 3000, and now after this is printed, my server is ready to get request. So this time I want to set a cookie. Now to set a cookie, we use the response object cookie method. The response object, you can set headers using the response object, and we said that the cookie is a header, so it's logical that we'll set a cookie header using the response object. Now a simple thing you can do is go to your browser, type Express.js docs. I always recommend when you start a technology, open the official documentation of that technology. So type in Google Express.js docs, go to the first option, and we're going to the API reference. By the way, Express, as stated here, is very minimalist, so you can probably finish reading the documentation in about 1 or 2 days. There's not a lot of things here, so I highly recommend to read along when you use Express. It's very easy to become a master in Express if you go over those things. There's also best practices and tips from experts that actually build Express. So I'm going to the docs, going to API reference, going to version 4, and I have here look how minimalistic it is. These are the major object that we have in the framework, and one of them is the response object. The response object is what we are getting in our middlewares. This is the response object, the second argument. Now inside the response object we have a method that is called cookie. So right here, response.cookie. So the first time you're going to use this method to set up a cookie, this method sets up a cookie, I highly recommend that you go over the documentation and read what Express has to say about this method. And going over the major things, this method gets two required arguments: an argument called name, the name of the cookie that you want to set up, and a second argument, a string value, the value of the cookie, and the square brackets here says that it's optional. And optional options setting up the cookie in different than the default that this method does. So an optional third argument, which we'll go over in a more complex example. But for now, we're just going to call this method. We're going to call the cookie method, and we're going to call it with a key. The cookie name will be hello, and the cookie value, hello world, our first cookie. This will set up a cookie. Now, when the browser sets a cookie, then the browser in the upcoming request to my server will automatically send this cookie. So we can create another path, app.get, let's call it the check cookie. And the check cookie, I want to print the value that the cookie of the set that I set up here. I want to print and when the user goes to the check cookie route. So in here, I'm gonna take the response object. I'm gonna take the response object and I'm gonna send the cookie value is, and we're going to the request.headers and we're going to type the header cookie. Remember, if it's with a small c or a big C, let's see, I think it's with not a capital C, but I'm just in case, I'm going to place a breakpoint here. So I'm grabbing from the headers. The request object has headers. The headers is a key value of the headers that was sent in the request. The browser sent a request with the headers. You can access those headers from here. Do note that we will see a better way using the cookie parser to access the cookies a bit more later, but I just want to emphasize that the cookie is a header and you can access that header from the request headers. So I'll place a breakpoint here. Now let's launch our app using the debugger. If I'm placing a breakpoint, I'm gonna use the debugger and click run in debug here. And now let's set up a cookie here in the root. So let's go to hello.com, which maps to our localhost 3000. Then this sets a cookie. Now let's go to the check cookie route. This should stop in our breakpoint. Now we can see what we have in the request header cookie. Using the debug console, we can print here what we have, and we have hello world, our first cookie is set up. So you can access it from the request headers. Now let's run along our app, and we see the cookie value is hello and hello world, our first cookie. Now the string we set is URL encoded. So instead of spaces, it marks %20. So this is the URL encoded of our cookie. So the default when you call response cookie, it will URL encode the key that the value that you are setting. So here's a simple hello world cookie. We set up our first cookie, and then we can see that we can access, the browser is automatically sending that cookie, and we can print that cookie on another request. So we managed to use cookie to transform a stateless HTTP to be stateful and access the cookie in an upcoming request. So a cookie is basically a way that we store information, and in every request that information will be passed along. So we basically store data that is passed along in every request. And in Express, we're doing this storing of data using a method on the response object called response.cookie. And we use that method, it's a function which gets a cookie name. In this example, hello, a cookie value in this example world, and some options like path, domain, secure, expires, etc. And then you can go along and modify the response object even further and send or send string or send file or change the status. But basically in Express, you set the cookie using a method called cookie and the response object. Now, one of the things that I emphasize in our lessons, we have to work with the right tools, the right debugging tools. So you have to know that you can use debugging tools to view your the cookies that you have on your site. And this is very important. I often visit companies, and it's always a surprise to me that a lot of companies with web application are not aware of the cookies that they are setting. And it's kind of weird thing to say, right? It's their web application and they are not aware of the cookies that they are setting. And the reason is that a lot of time, if you include an image from an external URL, if you include a JavaScript, if you place a snippet for a code for Google Analytics or whatever, a lot of times those external services are placing cookies in your site. Third-party cookies, which we'll go over soon in one of the examples that we go over that in this lesson. And a lot of the time, they have cookies that are not aware that they are set on their site. And immediately, my next question is, are you informing the user that you have third-party cookies, that they are tracking your activities? And obviously the answer is no, because they're not even aware of their cookies on their site. So there's an easy way to view the cookies and examine the cookies by using the browser developer tools. So let's do a small exercise. We have our app running. So we can open the developer tools, and in the developer tools, you have the application tab. So you have the application tab, and you see in the left side, you have the cookies. In Chrome, it's the application tab. In many browsers like Firefox, Safari, it's going to be named storage, because the cookies is some sort of storage that pass along in every request. But in Chrome, it's the application tab, and the storage is on the left side. And in here, you under cookies, you have a list of cookies that you're setting. Now, the cookies are arranged by a domain. So if you have third-party cookies, you might see here not just your domain, but many other domains as well. So if I click the my domain, I see that we set a cookie named hello with the value of the cookie and the flags of the cookie, which we'll go over soon enough. But those are the default flag. We didn't set any flags, so those are the default flag options. Now, you can also click the cookie, delete the cookie, clear them. So this is a good way to view the cookies in your site. Now, always be aware of the cookies that your site is setting, that you are setting. So sometimes you'll examine this list and you'll be surprised by the amount of third-party cookies that you have that you didn't even set. So be aware, always be aware of the cookies that your site is placing on the user, because you might need to ask them for their permission. We'll go over third-party cookies in the GDPR, the privacy laws that you need to keep to know when you're setting a cookie. So this is a good way to be aware of all the cookies that you're set, and be aware that many of the cookies here you didn't really set, you just included or placed a snippet of code and then it added a cookie to your site. So be aware of the fact that not all the cookies that you see here you actually set up yourself. You just copy paste or place some code or some call to external resource, and that placed a cookie in your browser. So we can go on ahead and we can view the cookies by opening the developer tools, and we can click the application tab, and on the left side we chose, in the storage section we chose cookies, and then you can see a list of all the cookies you have in your site. What are cookies used for? We have other ways to store data in our browser that will be available while the user navigates through our app. So what is so special about cookies, and what are we usually using cookies for? So cookies are a way of storing information in upcoming requests, while other ways of storage of information, for example, local storage or session storage, or the browser database, or storing in the memory of the browser, those are other ways of storing data in the client, and that data is available in the browser. While cookies is a way that the data is available in the browser, but it's also available for our server, because The browser can access the cookies. JavaScript can access the cookies if the httpOnly flag is not turned on. So you have access to them at times on the browser, on the client, but the browser also sends them to our server. So you have access to that data on the server as well. Well, local storage, session storage, memory, data, browser database, there's a way of storing that are available in the browser. And unless you take them out and send them to the server, they're only available in the browsers. So cookies are used for basically three things. One is what we saw, to store data, to store state. We use the cookies to store state that is available in every request we send, that is available in the browser as well. But we don't store, do not abuse this way of storage. You do not want to store every data, every state in the cookies. As I said, the browser has other mechanisms of storage like local storage, session storage. It is available in the browser, so do not always use the cookie. You shouldn't abuse the cookies to store data, since it's gonna make your request response cycle heavier. Think about this: when you store a cookie, it is sent on every upcoming request. And then every request will have the cookie header, and every response might have the set cookie header, and this will make the request response, the networking, heavier. You need to pass more information to the server in your headers. So do not abuse this feature. And basically the rule of thumb is, think about the things that you need that also your server needs. If you have something that only your browser, only their client needs, there is a good chance it's more suitable to store in other storing mechanism in the browser. What cookies are, the way of when you store things in cookies, they're available in the browser and in the server. So think about one thing: is the thing I'm storing, do I need it in the server as well? Let's say, for example, you want to you have a web application with a theme. You can change the theme to a light theme or a dark theme. Now you need to send that information to the server, because the server will send you different CSS files. You also need it in the client, because the client reacts differently when you have those theme light or dark. So a theme you might decide to store as a cookie. One other thing that you might want to store as a cookie, when you store in the cookie, it's available also for subdomain. So you can set a cookie that cookie will be available in the domain and subdomain. So if you want to store data and you want that data to be available in subdomains as well, you might decide to use cookies to do that, because local storage, session storage, database, they are per domain. They are not shareable in subdomain. So do not abuse. Place data that's relevant for client and server, and pass data that, if you have multiple domains in your web app, place data that is also relevant for other domains as well. And if you have a data that is you only need to access it in the client, you don't need to access it in subdomains, then you can use local storage and session storage and save the networking overhead of sending a cookie back and forth. This is one usage of cookies to store data and save the state. Another usage of cookies is to persist authentication. After the user logs in, after he authenticated, rather he entered his username and password, or he logged in using a Facebook button or a Twitter button or a GitHub or whatever login mechanism your site has, you want, after the user logs in, many times you want to persist that login, meaning you don't want the user to always click the login with Facebook, to always enter his username, his password. You want him to do it once, and then you want to do something in the cookies so you'll be aware that the user already logged in. So what you usually do, you either place a session identifier in the cookies, or you place a secret token like a JWT. You keep that cookie secure. We'll emphasize this in the lesson. Authentication cookies, there are certain rules that you need to keep, that you need to take into consideration. It can be abused if you do not use it in a secure way. You also need to know, like, the CSRF attack and other security breaches you might have. So you do have to maintain that cookie in a secure way. But often we use cookie as a meaning for a web application to log the user once and then persist the authentication using an authentication cookie. And the third usage of cookie is analytics tracking. So let's say I want to track the user like Google Analytics. I can place a cookie on the site, and then since the cookie will be sent, I can place a cookie that the domain of the cookie is to Google Analytics, and every request sent from my site to Google Analytics will send that cookie, and then I know that the same user visited my site, the homepage, the about page, the contribute page, and so forth. And this way I can track the user behavior on my site. Moreover, some sites use something called third-party cookies, and then they can track also the behavior of the user across different sites. So then, since the cookie is also sending on different site, we'll talk about third-party cookies, I can actually track the user navigation behavior. So if he navigated to my site and then to a golf site, I might put an ad, decide to put an ad about golf equipment or something in that manner. So cookies are also used to track for analytics, to be aware where the user navigates to my site, to my subdomain. So it's a good way to track the user on my site, but it's a good way also, it's used also for tracking across multiple sites and examining the navigation behavior of the user. So cookies are used to store data and save the state. They are used to persist the authentication, and they are used for analytics and tracking. This is the main usage of the cookies. Who can set the cookie? We already saw that our backend, our Express app, can set a cookie using the response object cookie method. So we know one way to set a cookie is using our backend, in our case Express, in our backend application. But another way to set a cookie is using client JavaScript. So a browser can run a JavaScript client script that uses document.cookie to set a cookie from client JavaScript. So one way is client JavaScript, and another way is from our backend web server. Let's go back to our code and see how we can set a cookie using client JavaScript. I'm going to add in my app another route, and the route will be to a set cookie client. And this route, what it will do, it will take the response object and it will use send file to send an index.html file. So we're going to send an index.html file to our browser, and I'm using resolve, so it will place the exact path of a new file called index.html. And in here, I'm going to place a simple HTML. Now, this will launch a site that will place h1 with, let's say, set cookie from client, and I will run JavaScript in this file. I'm not going to run JavaScript from an external script, like I'm not going to load main.js, because this will require us to add another route to our Express. Let's be a bit more lazy and add our JavaScript using a script tag. I'll add here JavaScript to set a cookie from the client, and I can use the document.cookie to set a cookie called client says hello world. And then I can set the options for this cookie. For example, I want this cookie to be sameSite none. We'll talk about the options, the cookie flags, later on this lesson. So let's remove the loading of CSS as well, and let's reload our server and go back to our browser. And now we have a new route, set cookie client, and this runs the cookie, this runs our index.html with the script that we just saw. Now let's see that the script is working and the cookie is set. And we already know how to check our cookies. We can do it using the developer tools, right? So I'm opening the developer tools, I'm checking the application, and my cookie is not set. I see only the cookie from the backend Express. We set a cookie called client hello. So why did our cookie why didn't my cookie was set? And I see here X marking there is a problem, and if I click here I can see mark cross-site cookies as secure to allow setting them in a cross-site context. So he doesn't like the option sameSite none when it's not added another option called secure. We'll talk about those options later on. This is why I set up my playground to serve a secured location. Otherwise, some flags won't work. So now if I go back to my browser and I reload, I see that a cookie is set properly. So listen to those flags here. Sometimes if you see a problem with the cookies, the answer will be flags you see in your developer tools. So we managed to set a cookie from our client JavaScript. We can set more cookies, okay, using calling document cookie again. So we can say document cookie foo bar, and this will set another cookie foo bar. So let's go and check out that it's working. And now we have foobar as well. So we managed to set cookies from our clients. So you can use your client JavaScript to set a cookie using document.cookie, and then you place a cookie and you separate the options. Of the cookie, like the example here. You can also set a cookie from the server, which we already saw before. Now in Express, we're using the response.cookie method. Now let's examine what happens in the browser when our Express is calling set cookie. So in our code, to set a cookie from our backend, we're using in this route, we're using the method response.cookie. So let's go back to this route. And we have the hello world, and let's see what happens in terms of networking. So let's go to the network tab and examine the network calls that we have here. So let's mark it to all requests. So we see the hello.com, the response header, have a set cookie header. So this is what this method is doing. The response.cookie cannot directly tell the browser to store a cookie, obviously. So what it does, it sends a header in the response called set cookie. This tells the browser that the server that it just communicated with wants to set a cookie, and then the browser sees that header and sets the cookie according to the header value. So when your backend is setting a cookie, basically the cookie is stored in the browser. The way it's stored in the browser is by Express or your server sending a set cookie header, and this tells the browser that your backend wants to store a cookie. So the function for the cookie, simply set a header called set cookie that tells the browser to store a cookie. When the browser sees the set cookie header, it will store the cookies. That header also contains the cookie options. We'll talk about the cookie options soon. So when I'm calling in in Express response.cookie, it sends in the response a header called set cookie. In Express, we usually read the cookies from the request using a lightweight middleware called cookie-parser. So up until now, when we want in our server to read the cookies, we would go in our code to the headers. Since a cookie is a header and all the cookies are sent using the cookie header, we can access the cookies using the request object in Express, the headers property that lists all the headers that are sent in the request. And in it, we add the cookie header, and this way we can read the entire cookies that are sent to our Express server in a single string. But this is not that comfortable since all the cookies are sent in the header in a single string. So what the cookie parser is doing, it's going to help us parse that single string that ships in the cookie header. It will help us parse that single string and arrange the cookies in an object, right? The cookie has a key and a value for each cookie we set. So an easier data type that we can use, we can arrange the cookie in an object, and this is what the cookie parser is doing. It's gonna parse the single string, the cookie header, and it's gonna place everything in an object where the keys are the cookie keys and the values are the cookie's values. So the cookie parser is a simple taking the request headers, the cookie header from the request headers, and parsing it and placing it in an object. And what it gives us, it will give us, instead of accessing from the request header, it will place in the request an object called cookies. So let's examine this. So instead of accessing the cookie using the request headers cookie, we can now access the cookies after we install the cookie parser. We can access the cookies in an object. So accessing the hello cookie is simply going to the request object cookies object, which arrange all the cookies, and accessing the hello cookie. So let's see this in action. So I'm going to use the cookie parser, but to use it we have to install it. So let's close our server, go to the terminal, and let's do npm install cookie parser. Cookie parser. So I'm using npm to install cookie parser, and now going back to our code, I'm going to import cookie parser from the install package here, and then I'm going to use install the middleware by taking Express app and using app.use, and in app.use calling the cookie parser creation middleware function, just calling what I imported here. Now whenever I have cookies, instead of accessing them through using the request.headers, I can do this. I can access those cookies using request.cookies. So the middleware is taking the request object and it's adding an object called cookies, and in here we can access the hello or whatever we named our cookie. So our cookies are named, if we examine our name, foo, client, and hello. So now our object will contain foo, client, and hello. So instead of printing the entire string, we now have an object, and we can access request cookies hello, and we can access request cookie foo, and pretty much access the cookies that are sent in the request. So the cookie parser is how we access those, is an easy way to access the cookies. It simply takes the request object and arrange the cookies in an object. Now if we relaunch our app, so let's run our app again and check that the check cookie is indeed printing our cookies. So let's go back to our browser and go to check cookie, and we see that the value we get is hello world, our first cookie, and bar. So we got the two cookies are printed. So use cookie parser to easily access the cookies from the request object cookies object. So cookie parser is an easy way to access the cookies that are sent in the request to our Express server. When you're setting a cookie, you can set options for that cookie. So we call those option cookie flags. And cookie flags can determine if your cookie is sent on secure connection, if your cookie can be accessed from JavaScript, if your cookies is only sent on sameSite, your cookie expiration. So you have various options you can attach to the cookies that the browser will know when to send that cookie. So examining our code, if you're setting a cookie, for example, we use the response object.cookie method to set a cookie. The first option is the key, the second option is the value, and the third option is the flags of the cookie. And in here you have different flags you can use to tell the browser additional things about the cookie you're sending. For example, you can say that your cookie expires at a certain date, and then you place to do that, you set an object and you place it what expires expect to get. So this is how you set the cookies, the cookie flags in Express using the third argument of the cookie method. But we said we also can set cookies using client JavaScript, right? In our index HTML, we're sending a cookie using document cookie API. In here, you're setting the flags by separating them, separating the flags, so setting the cookie itself and then marking the option, which are separated by those markers here. So in here, I set the option sameSite and the option secure. Now, when we examine the browser, and if we open the developer tools and go to the application tab, the flags that we're setting are in the developer tool. So you can examine the cookies name, value, and the flags, domain, path, expires, etc. And we will go over those flags now because it's very important to understand what those flags means, as well as the best practices for using those flags. The first flag we're going to explore is the cookies domain flag. And the domain flag is a way for you to set the cookie domain or subdomains that the browser will send the cookie. So I can say to the browser, this cookie should be sent on this domain or subdomain. And the default value is actually the limiting. So let's see a possible values we can place in the domain flag. So going back to our code, I am setting in line 14 a cookie, and the most limiting option I can set is do not specify a domain. If I'm not specifying a domain, let's if I'm not specifying a domain, then the domain will match the request host. request host only. So if the request is sent from the domain, let's say xyz.academies.com. So if the request is sent from here, the cookie domain will be sent to this domain only. So this means the cookie will not be sent in the parent. Oh, sorry. It will not be sent on the parent yz.academies.com, and the cookie will not be sent in the children xyz in, for example, d.xyz. So it will only be sent in xyz. So not specifying the domain is actually the most limiting option, and the best practice is try to set the cookie to be sent on the minimum domains that it needs to be sent. So if you only need the cookie to be sent in my domain, do not set a domain. So try to limit the cookie to the minimum amount of domains that it actually requires. The reason is because this cookie is sent on when the domain match on every domain or subdomain that match, and it will make the networking heavier. So if you omit this cookie from certain domains, the networking will be faster. So try to limit the domains as much as possible. And if you only need the cookie to be sent in this domain, do not place a domain. Now, other options we can set here, so we can take the cookie and we can specify a domain if we do want the domain to be available in certain subdomains. So we can specify a domain here, and let's say our cookie is sent from this. I can specify a domain to be, we start the domain with a dot, and now the domains that the request is sent from. And when I'm placing this value, this means that the cookie will be sent in obviously my domain xyz.academies.com, but also in my subdomains. So the cookie will be sent also to my subdomains. So for example, d.xyz.com. The cookie, however, will not be sent in my parents. So for example, yzacademies.com, this won't be set. So try to limit to the minimum amount of subdomains. Another option, popular option you can specify in the domain is doing something like this. This is also valid. I can specify my parents. If I'm sending the request from xyz.academies.com, I can specify the request to my one of my parents, y or y.z or z.academies.com or .academies.com are all valid options. So I can look at my parents and set a domain here as well. And this means that the cookie will be sent obviously in the domain yzacademies.com. It will be sent here. It will be sent also all the subdomains of yz. So obviously it will be sent to my domain xyz, as well as it will be sent to my brothers. So I can share a cookie information with my brother's subdomain. So it will also be sent to dyz.academies.com. But it will not be sent. The cookie will not be sent, for example, in the parents of y in z.academies.com. So this way I can specify, include subdomains, and share that cookie value with my brothers, with my brother's subdomains. So let's see if I specify response.cookie for the domain. Let's specify hello.com. Since the request is we're sending the request from a domain we created, hello.com, we can specify the possible values. We can specify either hello.com with a dot to include subdomains, or omit this to without domain, omit the domain, so it will be sent only to hello.com, not to the subdomain. So the possible values, if we're sending the request from hello.com, our possible values are pretty limited. One thing we cannot do is if we're sending the request from hello.com, we cannot specify children. So we cannot say we're specifying a cookie for x.hello.com. We have to take the request origin and either take our domain or our parents' domain. So this is since we're in the root domain hello.com and not in the subdomains, our options are limited. So let's see, I'm setting a request to domain hello.com, and let's relaunch our server and examine this cookie. Now going to the browser, if I'm examining this cookie, going developer tools and opening application, I can see that I set the domain of the cookie to hello.com. So yeah, you can set the domain to include subdomains. You can set for your parent domain. So an example in this slide is setting hello world to, if I'm sending the request from academies.com or academies.com subdomains, I can set a cookie hello world to for all academies.com subdomains. After limiting the domain, so the cookie will be sent to the minimum domains and subdomains, we can also limit the path. So try to limit the cookie using the domain and using the path to limit where the cookie need to be sent and not more. So the path is the request path that we're sending from. So the browser, when you're sending a request, the request has a host and has a path, and the browser will send the cookie only if the host match the domain and only if the path is matching the path that the cookie is set to. So the browser, basically this flag means on which path should the browser send the cookie. And the default is that the cookie will be sent on all the path. So the default is not as limiting. So the domain default was very limiting to a single domain, but in here the default is not limiting and it's sending the domain on every request. So let's see in the example here below. I'm setting a cookie and I'm setting the path to be accounts. Again, the path gets, like the domain, it gets a string with a path folder. So this is the prefix of a folder. So in this example, if the request I'm sending is to a path that starts with accounts, meaning accounts and accounts foobar, for example. So every path that starts with the path account, so basically the path is a prefix of a folder. The browser will send that cookie on accounts, accounts foobar, etc. But the browser will not send the cookie on accounts 1 because the folder has to be named accounts, or accounts 1 foobar because the prefix folder has to be named accounts. So looking at our code, I can set the domain to be hello.com and I can add here a path. So the cookie will only be sent in, for example, let's say the path check cookie. And try to limit the cookie as minimum as possible. So for example, let's say you have an API public that starts with API public for every REST API that is open for everyone. For API public, I don't know, like languages. This is open for everyone. And let's say you have an API for restricted, for logged in user. API restricted, and for example, grab my user. So in this case, for example, you can set, if you have an authentication cookie, you might want that cookie to be sent only on path that starts with API restricted. So you might set your authentication cookie, let's say the name of the cookie is JWT, some secret authentication cookie, and I'm gonna set the path to start with API restricted. So all the requests to API restricted will send the JWT cookie. This way, you are saving the JWT cookie from be sent to other URLs where you don't want to send this cookie, and you're saving the network bandwidth. So consider limiting with the path. Now, if I'm limiting, for example, let's restore this one. If I'm limiting to check cookie, let's restart our server. And let's examine the result. In hello.com and subdomains, I'm setting a cookie that will only be sent on the path check cookie. This means that if I try to print the cookie here, I won't get the cookie because it's only available in the check cookie. So if I'm trying to print, can I access, let's see, let's make it a bit more, dropping the line. Can I access the cookie? Let's try to access the cookie hello, and I shouldn't be able to access that cookie since that cookie is only available in the check cookie domain. So I'm gonna try to print request.cookies dot hello, and I should be getting anything. On the other end, in the check cookie domain, I should be getting my cookie. So let's restart our server, go back to the browser, visit hello.com. Request is not defined. Request here is not defined. Let's change it to request and restart the server. So hello world, our first, can I access the cookie? I see the cookie probably because I have the old cookie set. So I'm gonna delete this and set the cookie again. Now I get undefined as the cookie, but if I check the check cookie, I see that my cookie is set. The reason is because the path of the cookie is only in the check cookie. So again, you have the path to limit the cookie to be sent to certain path that starts with the prefix, in this example, check cookie prefix. So try to limit the cookie to be sent only when it actually needs to be sent. The next flag we are going to talk about is called the secure flag. And the secure flag, the browser will send, if a cookie is set with the secure flag turned to true, it's a Boolean value which can be true or false. So if a cookie is set with a secure value set to true, this means that the browser will only send the cookie if the request is sent to a secure in a secure way. That means HTTPS with a valid certificate. So the default is that the secure is false. But usually, I always recommend organization to serve their web apps on secure connection, HTTPS. Regardless of the security aspect, also adds you point in the search engine optimization point of your site. So I recommend all the sites to be secure HTTPS with a valid certificate. And if you're doing that, I recommend all your first party cookies, all the cookies that you're set, to be served in a secure location. I also recommend that your site will only be served on a secure location. So, and if that is the case, you have no problem setting the secure to be true all the time. So this is my recommendation. Sometimes there are organizations that do serve their apps on a non-secure location, and in that case, they have to distinguish which cookies they consider to be classified. They do not want anybody in the network list eavesdropping on the request and grabbing that cookie. So in that case, you need to limit the secure to true to every cookie that is you want to hide from unwanted listeners. So that means authentication cookies and such. But on general term, you should always serve your site on a secure connection. Also, HTTPS, TLS certificates are now free, so there is really no reason why you shouldn't be serving your site on a secure connection. So if that's the case, this is one of the flags that you need to set as true. So extra important, authentication cookies. Authentication cookies, you have to validate that your authentication cookies, the cookies that hold your JWT or your secret token or your session ID, those are cookies that have to be secure set to true. It's super important. Bear in mind that if the secure is not set to true, as somebody is sniffing in the network for request, the cookies header is open. They can read the cookie header. So think about if you have authentication cookie and it's not secure, somebody can grab your user authentication cookie and just use that cookie to authenticate on behalf of the user. So going back to our code, to set the secure flag, you set the cookie and you place a secure true. Remember that the default is the secure false. So going back to our code, I can say that my hello cookie is, I want to set the secure to be true. And now this cookie will only be set if the request that is sent is on a secure location. And let's check this out, how it works with the browser, how you check that it works. So let's reload our server, go back to the web browser, and let's see, we set the cookie here, right? So first of all, let's open the developer tools and let's delete the current hello cookie. Okay, great. Now I'll go back to the root where we're setting the cookie, and I'll notice that there is no cookie since we limit the path. So let's restore the path, remove the path for a while, so it's going to be easier to check. So let's restore our path and reload the server and go back to the browser. And now we see that we have a cookie set to hello.com to the path. And you notice that the secure flag, it's a bit hidden here, so let's expand it. Notice that the secure flag is marked with with a checkbox. This means that this will only be sent, this cookie will only be sent on a secure location. So now if I go to check cookie, I see our cookie, hello world, our first cookie is set and is sent. So great. We also have now another cookie with check cookie domain. So let's delete this. This cookie is a residue of the old example. So let's delete this. And now we have our secure cookie is set and printed. Now let's check an example. Our server is also running on unsecure on localhost 3000. So let's check the let's set the cookie here. Let's set the cookie, and we'll notice that there is no cookie set since we are not in a secure location. This means that when we go to check cookie now, we see undefined. So our cookie is not sent, so since we are not in a secure location. It's one of the reasons why I set the playground to be with a secure connection. It allows us to check this flag as well. So set your secure flag to true. If your site is only serving on HTTPS, just turn this flag on to set all your first-party cookies as secure. If you've seen my lectures before, one of the things that I emphasize in my lectures, it's always important to read the formal documentation. So when you're working with a technology, do yourself a favor, open in the browser a tab with the formal documentation, and when you're working with something in the technology that you didn't work before, do a quick read on the formal documentation. There is a lot of bad material on the web, and it's easy to fall down to a copy-paste pattern from Stack Overflow without really understanding what you're doing. So the way to really understand is also take time to read the formal documentation. So going over to Express.js documentation, going to advanced topics, there is a section called Performance Best Practices. And again, the documentation of Express.js, there's not a lot there. Express is very minimalistic. So go here, and one of the things that you should be aware is an environment variable called node-env. And in the best practice, Express, one of the recommendations of Express is to set the node environment to production. Now, this recommendation says that you should set node environment to production when you're running your app to production, when you're serving your app to your users. When you're developing your app, you can set the node environment to development. So make sure that when you serve your app, the node environment is set to production. Now, when you launch your app to production, the node environment is set to production. Now, one of the things that I'm doing, that usually I'm doing, so I'm usually the secure. And a lot of time I'm developing my app in a local host environment. That means when I develop my app, I don't do like I did today with a valid certificate and a secure connection. Although you can set your local development environment to work in a secure connection, at times I don't do it, and I just work in local host. In that case, I don't want to serve my cookies in secure when I'm developing. So I'm doing something like that. If my process.env node-env equals production. So you can do something like this, and let me just drop the line. So you can do something like this, and this means that the secure flag, when you're developing and working in localhost, the secure flag, your node environment is set to development, and in that case, the secure will be false. And when you're launching your app, you need to make sure that you set your process and node environment to production, and in that case, the secure will be set to true. So that's a trick that I sometimes use if I develop my app in a localhost and I don't want to be confused and launch my app to production without setting the secure to true. So the secure this way is a bit dynamic. So this is a tip. In general, what you need to remember that your environment variable called node-env should be set to production when you launch your Express application. And you have here a specification of what happens. So Express.js improved the caching, and one of the things, it's better security because the error messages are limited. So in development mode, it will print the entire stack trace, which we don't want to do for our user in case they stumble on one of our errors. We want to hide that for security reason and user experience. So make sure that you set the node-env to production when you're launching your Express app to production for your users. The next flag we are going going to talk about is the HTTP only flag. This flag accepts, like the secure, it accepts a Boolean value of true or false. When the HTTP only is set to true, this means that the cookie that you set HTTP only to true cannot be accessed from JavaScript. So you set HTTP only to true on a cookie, and JavaScript document.cookie API cannot access that cookie that is set with HTTP only set to true. And why do we need this? This is very important for authentication and secure stuff you're placing in your cookies. So it is very important, for example, for authentication cookies. Those cookies that store your secret code token, your JWT, your session ID, those need to be set to HTTP only set to true. They cannot be accessed from JavaScript. And the reason why it's important, because it makes you, if you take something secure like your session ID, and you're not setting for the session ID HTTP only to true, this means you are more vulnerable to cross-site scripting attack. This means that if someone somehow managed to embed a JavaScript to your site, he can take that cookie and send it to the hacker, and he can utilize this way to hack your users. So cross-site scripting is a way where a hacker can somehow place JavaScript in our site. For example, the most naive example is you have like a messaging app, and a user can post a message on a wall like Facebook, and you're placing a script tag in your message, and your application doesn't remove those tags, so other users will read the comment of the evil hacker, and they will actually run a JavaScript file. But this is a very naive approach. You can embed JavaScript in an image, in a link, in many other ways. So this is probably the most popular security vulnerability that exists, because there are many ways you can embed JavaScript in the URL. There's tons of ways you can place JavaScript on a site. And when someone is managing to place JavaScript in the site, if you have any cookies that is secure, that is not HTTP only, he can access those cookies and send those cookies to himself in order to hack your users. So very important to set the HTTP only to true on every cookie that you want to hide, like authentication cookies. Let's go back to our code, and let's go back to our code and go and set the cookie, hello cookie. So now we're setting it to secure, and we're setting this cookie to HTTP only set to true. So let's see what happens. First of all, let's see what happens without this flag. So I'm going to remove this flag for a second, just so we can examine the old app. The old app we had a cookie that is hello, that is HTTP only. HTTP only is here. It's a bit hidden. Let's do this. So the HTTP only is set here to false. This means that I can access the hello cookie from the document.cookie API. So I see, if in the console I print document cookie, I see the hello cookie. Now let's see what happens if let's delete this cookie. And now let's see what happens if I set the HTTP only set to true. So I'm setting the hello cookie, but this time I don't want it to be accessed from the document.cookie. So I'll relaunch my app, and I'll go back to the browser, and now I'm setting a cookie that, let's set the cookie in the root. I'm setting the cookie with the HTTP only turned on. So HTTP only is turned on, and now you have our secure set to environment variable. We can set the secure to be true as well. Let's place the secure to be true and relaunch our app. Go back to our browser, and now we have the secure true and HTTP only. So the HTTP only means that this cookie cannot be accessed from JavaScript. So if someone places a document.cookie, he doesn't see any hello that we saw before. Now imagine someone managed to embed a JavaScript in your site. He can use the document.cookie to access the cookie and send the cookies that's saved in the browser to himself in order to pretend is take someone authentication cookie and pretend he is that user. So make sure that every authentication cookie is set to HTTP only set to true to avoid accessing that cookie from document.cookie. The sameSite flag is a very important flag in terms of security. We will talk later on about a popular attack called CSRF attack, cross-site request forgery. And this cookie flag is another way we can help to prevent CSRF attacks on our site. So more on the security aspect of this flag we'll cover in a minute. But I want just for you to understand what the sameSite actually means before we dive into the security aspects. This cookie determines when the request, looking at the request origin, the request host, it determines if the browser should send a cookie or not, referring to the origin and where the request is sent. So let's say I'm on a site called foo.com. And I'm sending from foo.com. My browser is currently on foo.com, and it's sending a request to hello.com. So the origin of the request is foo.com. The destination of the request is hello.com. So the browser looks at the origin, and based on the sameSite flag, determines if it should send the cookie or not. Remember that the cookie that it determines to send is a cookie that was set from hello.com. So the browser sets a cookie when a request to hello.com is getting. But if the cookie that hello.com is set has a sameSite flag turned on, then if the user from another origin, from foo.com, sends the request, the cookie might not be sent. Okay, so in simple terms, a site sets a cookie and it determines with the sameSite if a request from a different origin should send that cookie when a request is made from a different origin. So there are a few options here, and we'll give an example of what I mean of origin. We'll give an example by code. So there are a few options that you can give to the sameSite flag. Basically, it accepts a string, and that string value can be one of those three options: none, lax, and strict. The default, by the way, is lax. So when I'm setting a cookie and I'm setting the sameSite to none, this means that I don't care what the origin is. I want the cookie to be sent even if the origin is foo.com. Now, when we're talking about the second option, if the sameSite is set to lax, in this mode, the cookie will not be sent when you send a request from, if a cookie in hello.com is set with a sameSite set to lax, then if foo.com is sending a request, it depends on what type of request is sending. If it's sending a navigation link click, if the user just clicks a link to navigate to hello.com, it will be sent. If the user types a URL in the address bar, it will be sent as well. But if it's a different request, for example, from foo.com sending an Ajax post request, then it won't be sent. So it's only gonna be sent to ordinary GET requests. So this is the lax mode, and the strict mode is just sending if the origin of hello is from hello.com. So in this mode, the strict mode will not send the cookie if you're typing an address in the address bar. If you're not in hello.com, opening a new session in the browser, typing hello.com, the cookie won't be sent. As well as it won't be sent if the user clicks a navigation link from some site, facebook.com, clicks a navigation link to hello.com, the cookie won't be set. So usually the default value for authenticate, the default value is lax, and for authentication cookies, we either use strict if it's possible, because sometimes we want authentication cookies to be sent when the user types a URL in the navigation bar or follows a link. And if we can't make our authentication cookies strict, because the user can come from outside of our site, then authentication cookies should be set to lax. Now, to set it the same way, third argument, sameSite, you specify none, lax, or strict. Now, let's see a code example that might explain better those sameSite flags, non, lax, strict, and we will try to create two domains. We're going to try hello.com and create another server in evil.com, and then we'll try to use those flags and see if evil.com is sending that cookie if it was set with sameSite, none, lax, or strict. Going back to our code, let's try to do a small demo to demonstrate the sameSite cookie flag. So I'll go back to the IDE, and because the sameSite is I think it will be much more clear after a demo, but let's start on a new clean slate. I'll close the currently running server, and I'm not going to work on this file since I don't want to confuse you. I just want to focus on the sameSite flag. So I'll go back to the files, and let's create it in a new files, a new folder, and I'll create a new folder called sameSite demo. Inside this folder, let's try to describe the exercise we are trying to do now. So I'll create the sameSite demo. I'll create a README file. And let's talk about the exercise and what we are supposed to do here to study the sameSite flag. So let's call it sameSite exercise. So our goal is this. We are going to create two servers to demonstrate the same site. I want servers on different domains to send requests to each other. So I'm going to create an Express app, listening on port 3000. This will map to a domain hello.com with a secure valid certificate. And I'm going to create another Express app listening on port 3001, and I will map this also secure to evil.com. Now I have two domains. We already set the playground, created our reverse proxy with a valid certificate. So all we need to do is create an Express app running on those two ports. After that, I'm going to try to create a cookie set in hello.com. So hello.com will have a domain, let's say it's the root domain, that will let's create a file, create a JavaScript file with a cookie. Now, evil.com will call the hello.com script. And this will create a cookie with domain hello.com and in the domain evil.com. So evil.com is going to send a request to hello.com, and that request will set a cookie with sameSite set to none with the domain hello.com. So evil.com now has a cookie that should be sent to hello.com, and then we will send a request. Evil.com will send a request to hello.com and examine if the cookies are sent or not. So let's do this exercise and we'll demonstrate. Right now we'll do sameSite none. After that we'll create the same cookie as sameSite lax and sameSite strict, and we'll observe the differences between the different sameSite values of a cookie set in a domain hello.com. So we'll create the sameSite demo folder, and inside let's create two Express app listening on port 3000 and 3001, and we actually have a check playground file with a simple Express server listening on port 3000. So I'll take this file and I'll just duplicate this file in the sameSite demo, and I'm gonna rename this file. Let's call it hello.mjs, and this open an Express app listening on port 3000 sending hello.com. Great. We'll duplicate this file and create another server running on port 3001. So I'll create another server, copy that file and call this file evil, and now this Express server will listen on port 3001, and we'll send in this path, we'll send hello evil.com. Great, so now we have our two servers. Let's try and run those servers and examine the result. I think I have something running in my debugger. No, I don't. Okay. Okay, so let's try and run those two files and examine that we have evil.com and hello.com. Both are running. So I'll run node sameSite demo and start with hello.mjs. This is running on port 3000. And evil, let's say it's printing, I'm running on port 3001. So let's open another terminal and launch the second file, sameSite demo evil.mjs, which is listening on port 3001. And now if we open our browser, we should have hello.com running, and in the domain hello.com, as well as evil.com running. And in case we do have cookies for hello.com, let's clear all those cookies. So I'll open the developer tools and I'll go to application, examine that all our cookies are clear. I'm gonna just clear the cookies so we can actually start on a clean slate. Great, now it's time to actually try to set a cookie from hello.com, and that cookie should have a sameSite none. And then evil.com will send requests to try and check if that cookie is sent or not. So we now have evil.com and hello.com running. Let's set our ID to be a little bit organized. I'm going to place evil.com code on the left side, and let's close everything. And on the right side, I'm placing hello.com. And let's just add our mark here so we'll know on the left side we are talking about evil.com server, and on the right side we are talking about hello.com server. Great, we have our two servers. Now hello.com will create a route which sets a cookie. And that route, let's say that route is for a file. Let's say for a file called hello cookie.js. And this route will send a JavaScript file, and as well as set a cookie. Great. So let's create this hello cookie.js. So I'll go to the files and I'll create a new file and name it hello cookie.js. And this is a JavaScript which won't have a lot of code, just console log a message, so we know that this file is loaded successfully. Loaded JS file from hello.com. Great. And going back to the hello.com server, when the user will go to this route, it will response send file resolve for sameSite demo hello cookie.js. So it will simply send a file. Now to see that it's actually working, we can rerun our server running on port 3000. This is my first terminal listening on port 3000. I'm going to close this and I'm going to rerun the hello server again. Now going back to hello.com, I have a new route, hello cookie.js. So I can see that I can examine this file, hello.cookie.js, and we see our file is actually serving. Great, so this is working. Now we go back to the code, and before we are sending the file, we can also set a cookie. So notice that a cookie can also be sent if you include a JavaScript from a different server or an image from a different server. If you have something that is calling an external domain, that external domain might set a cookie with the sameSite none in your domain. So this is why I always say when you use external resource, make sure to check if only if it's even if you're aware that this external domain, does that external domain set a cookie or not? You should be aware of that fact. So in here we are doing hello.com external domain, which actually set a cookie. We'll set the cookie hello. Cookie name will be hello. Cookie value will be hello world from hello.com. Now in the flags section, I can add the flag sameSite set to none, and I can also, if I want to set most of the browser has a security default where when you set the sameSite set to none, you have to set the secure to true. Otherwise, browsers usually won't set will send a fail message about setting that cookie to sameSite none without the secure set to true. And this is the behavior in the Chrome as well. So I'm going to set sameSite none, but I'm also going to set secure set to true. Now, just to examine that our cookie is working, we can reload our server again and go back to our browser and examine the cookies and see that if we reload, we have a cookie with sameSite none and secure set to true. Great, our cookie is set. Now let's go back to our code and let's start working on evil.com. Now evil.com will just when you go to the root path, it will simply send a file of index.html. So we'll create an index.html file. And HTML file. In this file, we're gonna place a sample HTML. This HTML file will run on evil.com. So this is evil.com site. And what it will do, it will load a JavaScript from the domain of hello.com. So we will load the hello.com script we created, hello cookie.js. Great. So now let's go back to our server. Evil.com is sending a file to resolve. Let's resolve. It's sameSite demo index HTML. Great. So this file is actually including a script from hello.com. Think about Google Analytics, certain third-party analytics that you use on your site. A lot of them are setting a cookie with sameSite set to none. If I'm not mistaken, Google Analytics does something similar to that. So it places a cookie with sameSite none. So if your site will your site, you also include a script for Google Analytics. So that script can send requests to Google Analytics and send that cookie to know information about that user, because he has a cookie which is always set at the beginning and always sent on request. So this is something similar to something that analytics, third-party analytics that you embed on your site are doing. So we're sending a file, index.html file, and let's reload the evil.com. So port 3001, I'm going to close this. I'm going to run evil, rerun the evil server, go back to our site. So if we go to evil.com, we should see the script is running. If we examine the cookies, we should see that since we included the script, the hello, we included in the index.html, we included the hello cookie.js, we actually set a cookie in evil.com to map to the domain hello.com. This is actually referred to as well as third-party cookies. A cookie that is not set by evil.com, it's not set by your site, it's not a first-party cookie. First-party cookie is cookie that are set by your site. It's a cookie that was set by an external site, hello.com. We refer to this as third-party cookies. Now, using the same site, we'll examine when does this cookie is sent. How does the same site affect cookie sending? How does the browser look at the same site and determine if it should send that cookie or not? So let's send a request from evil.com to hello.com and examine the cookie. So in evil.com, before the body ends, I'm going to send a script tag, and I'm going to send a request, a fetch request, sending to hello.com to, let's say, the route check cookie. We'll create in hello.com a route check cookie. So going to hello.com, I'm going to create a get request to check cookie. And this route will send the cookie. So it will examine if we have an hello cookie, and then it will send that cookie back. So what we'll do here, we are going to send a response, a JSON response, and the JSON response will have hello set to request.cookies cookies at hello. So if we're using the request cookies object, this means we have to install the cookie parser. So let's go and import our cookie parser. And let's install it by taking the Express application and using the cookie parser middleware. Now we can access the cookies using the request.cookies. So what I'm doing in the check cookie, I'm sending a JSON with the content of the cookie hello. So this will only work if the evil.com is sending the cookie that was set from hello.com. If evil.com is sending the third-party cookie, the hello.cookie, this will work and show the result. If the cookie was not sent, it will fail. Now let's resolve this promise, and in here when you fetch, you get in the promised result, you get a response. And let's return the response JSON result, and then append another then that will contain the JSON response. And in here we're going to console log that JSON. So if we manage to send that cookie, we should send we should see we are getting back hello and the world from hello.com response if it works. Now, some of you might have noticed we have a problem here sending a request to different domain. We're sitting on evil.com and we are sending a cross origin request from evil.com to hello.com. So let's see the result we are getting. Of course, before we do that, we need to reload the hello server since it's changed. So I'll go back, listening on port 3000, reload our server, and go back to the browser and relaunch evil.com. Now I see a bunch of errors listed here and a bunch of error flags listed. Let's read all of them and try and understand them. Refuse to apply style. This regards to some styling we're setting here, which should not be here. So let's delete this. Access to fetch at hello.com check cookie from origin evil.com has been blocked by CORS, cross-origin resource sharing. We are not going to talk too much about CORS in this lesson, but I'll have an entire lesson about CORS and the best practices you should be aware when using CORS. In this lesson, we are not using the best practices in terms of CORS, since our focus is on cookie. So don't crucify me on that. Focus on the cookie, not on CORS, and also not gonna solve it as ideally as it should be. Again, we're focusing on the cookie. Sorry about that, but we will have an entire lesson about CORS. Anyway, we're then, since the CORS failing, our GET request is failing as well. So this is the error that we have here, error in the fetch. So let's try to solve our CORS problem before we actually can send that request. We need to solve our CORS problem. Solving our CORS problem is a matter of opening the terminal, installing Express middleware. So we are npm installing an Express middleware called npm install CORS. So it's a matter of installing a middleware and telling Express we need to go to the hello.com and tell this server that we are support request from foreign domains. So what we can do is, after installing the CORS middleware, we can take the Express app and use that middleware. So I'm gonna import CORS from the package I just installed. The package name is CORS, and then I'm gonna app.use CORS. And what this middleware is doing on CORS, when you do a foreign request from evil.com to hello.com, evil.com, the browser, automatically sends a pre-flight request. And basically, the pre-flight request is meant to ask the hello.com, am I allowed to send request? Look, I'm in a foreign domain. Am I actually allowed to send this request? And what the CORS is actually is grabbing that pre-flight request and is sending back a response. Yes, you are allowed to send a request. So this will respond to a CORS pre-flight request. And what it will respond is it will add an header called access control allow origin, access control allow origin, and it will just mark it as everyone is allowed to send request. So this is not the recommended way to solve CORS. It's actually not a good practice to allow every server to send foreign requests. And basically by doing this, you're exposing yourself more to CSRF attacks. So this is not the recommended way, but let's, for the sake of studying only cookies and focusing and actually showing security vulnerability, I will allow to use this, but in general, I wouldn't recommend to solve the CORS problem like this. So after I did this and installed the CORS middleware, the request from evil.com should be allowed now. So let's reload the hello.com. So sorry. So this, I'm gonna do load the hello.com server, and I accidentally closed the evil server as well. So I reload the server. Now let's try to send the request again. So I'm going to evil.com, and this time the request actually passed, and I got back a result. Not exactly the result that I was expecting, but let's try to examine the request that I sent. So I sent a request check cookie, and you'll notice that in the request, I didn't send the cookies header when I send the request. So obviously the check cookie, which returns a JSON with the cookie hello, it did not, if we examine the request did not, the request that I sent from evil.com does not include a cookies header. This is why this was not processed correctly, the request.cookies hello. And the reason the cookies header was not sent is that the fetch method that we are now using is stripping credential, is stripping the cookies header. And if you want to send the cookie header, you need to add an object and add credentials set to true. And this way the fetch would not strip the cookies header and will send the cookies header as well. So let's try to send that request with credentials set to true. I want to allow to send the cookies. So let's go back to our browser and this time reload and check the network again. This time I think I get an error. Okay, so failed to execute fetch on Windows, failed to read credential property from request init. The provided value true is not validating value of the request credential. I'm sorry, it's not credentials true, it's credentials include. Sorry about that. So let's try to reload our app again, and this time we have a different error. The error actually originates from the hello.com server. The hello.com by default does not allow to include the credentials from another site. That's another aspect of a CORS problem. So you don't only need to allow resource sharing from evil.com. You actually, if you want to include credentials from evil.com, you need to allow that as well. So let's solve this problem and open our CORS a bit more. In hello.com, we'll allow sending credentials from evil.com. Okay, so to solve our extra CORS problem, let's call it like that, our hello.com has to also allow credentials. It's not enough to simply app use CORS. We need to also set options in the CORS, and we need to add credentials set to true. I think it's a Boolean value, credentials set to true. And that's not enough, credentials set to true. We also need to add origin. We're allowing the credential, send credential from the origin of evil.com. Okay, so and this way it seems like CSRF, it's not actually possible, but this only happens on special requests like AJAX requests using fetch. Regular request, and we'll talk about it in the CORS lesson, regular GET request or regular form tag post request, the browser is not even initiating a CORS. So this will not trigger a CORS. So it might seem less possible for CSRF and special fetch request, but hackers can make requests seem like ordinary GET request or post request, and in those requests, CORS will not be triggered. And we'll talk about it more on our CORS lesson. By the way, a link to the CORS lesson you have below, so make sure to check it out and follow and learn more about CORS. I also added CORS as a prerequisite of this lesson, so make sure to check it out before you move along. So we need to use CORS and allow credential true and origin. Now, after we do this and we also reload the hello server, the hello.com server, let's see what happens. Let's go back to the browser and let's reload, and now we're actually getting a response. So the cookie was sent. How do I know the cookie was sent? I can check the network and I can check the check cookie. So a request from evil.com, a request to hello.com included in the request included the cookie that was set from hello.com. Okay, and this is a third-party cookie. We actually managed to set a cookie, and we saw what happens with the same site with the same site flag. When we set the same site flag to none, the browser can send the cookie from a different domain. A cookie of hello.com, the browser can send that cookie from a different domain. So we saw an example of same site set to none. Now let's try to play a bit with that flag. Now that we understand same site none, it will send the cookie, and it is a way to set a third-party cookie. So same site none will send the cookie from a foreign domain. Let's see the other option. Let's see the lax option. Same site can have three values, either same site set to none, lax, or strict. So let's check what is the lax. What does it mean for the same site to be on the lax? When will the browser send that cookie if it was set to same site lax? So when we set the same site to none, the cookie that was set on hello.com was sent from evil.com on the cases. So evil.com did send on pretty much every request that passed CORS. So your request has to pass CORS. And CORS depends on hello.com settings, but it also depends on the type of request. Some requests that you are sending will not trigger CORS. So regular GET request, form post requests will not trigger CORS. Also, if the user has an older browser, so CORS might not be activated. So every request that pass CORS will be sent, and also every request that does not obviously fetch the cookie, that does not strip the cookies header. So you have to include credentials. Include the cookie header. Fetch will strip by default the cookie header, as well as other many AJAX sending method will strip the credential. You have to specifically say to include the credential. So this is the same site none. So the same site none might be usable if you in cases where you want to track the user. So if you have some kind of you're providing a service where for developers that they need to embed a code, like a snippet of code, like for example, Google Analytics, when you want to include it in your site, you have to embed a snippet of code. So if you have some kind of site that you have to embed a snippet, that you want to, for developers to embed a snippet of code, and you want to track the user with sending requests and tracking the origin of the setting a cookie and tracking the origin of the user from which site, so you can use cookie with same site set to none. So this is a good use case if you have a case where you need to track your users across different sites. Bear in mind that some browsers are by default preventing third-party cookies. They will disable they will not send those cookies. For example, Safari and Firefox new versions are not disabling third-party cookies, as well as Chrome will probably in the near future. The new version will also disable the third-party cookies. So bear in mind when you're using when you're relying on tracking with third-party cookies, that the future might not be that positive for doing so. So bear that in mind. Of course, if the user is still using an old Safari, old Firefox version, so the third-party cookies will still be sent. So this is the same site set to none. Now let's explore the other options. So another options which same site is the most unrestrictive, so it will be sent regardless of the origin. But if you want to restrict your request more, and by doing so prevent a lot of CSRF use cases, so I can set the same site to lax, and I want to explore this option specifically. I want us to be aware of when does a lax cookie is sent when sending request from a different domain. So I want to understand exactly when does the lax cookie is sent when I'm in evil.com. So what I'll do, since I changed the hello.com, let's reload again the hello.com, and let's go back to the browser, delete the old cookie. So I'm gonna delete this cookie, and I'm gonna set my new cookie to be of type lax. Now I have a cookie I'm in evil.com. I have a cookie for the domain hello.com, and I'm in evil.com and I want to send a request and understand when that cookie is sent. And obviously the old request that we made, the old fetch request, so let's check this request. We go to the network and check the request check cookie. We see an empty object. This is because our request did not send the cookie header. If we'll examine the request headers, we will not see the cookie header is sent. So this is a difference from one difference that we had from the same site none. So on special request, special Ajax request, like we did here, even if the credentials include, it doesn't matter if it's on same site lax, evil.com will not send that cookie. The browser will not send that cookie. Now I want to examine as well, when does the browser actually send this cookie? So we notice that fetch and special Ajax request will not send the cookie, but are there requests from evil.com that will send the cookie if it's set to lax? It's actually important for us to understand when lax is sent, because it makes us understand how hackers can make even a cookie with lax, on some cases, can have a CSRF attack, and we can have security vulnerability. Even if we have a cookie same site to lax, we still might be vulnerable on some requests. So it's important to understand, if I set a cookie to lax, when does this cookie is sent if I'm on evil.com? There are two cases where a cookie with same site set to lax will be sent. The first case is navigation links. So if evil.com has a navigation link, so an anchor tag with a link to hello.com, and let's link to the check cookie so we can examine if the cookies are sent. So a link to the check cookie. So in this case, cookies with lax are sent on navigation. Now, navigation links can be the anchor tags, and also they can be, you can navigate the user using JavaScript as well. So you don't have, so an attacker can simply be enough for him for a user to click a link and go to a site, and he will navigate to a third party site. So it doesn't have to be like waiting for a click of a user. It could be ignited by JavaScript. So one case is an anchor tag. So if we go back to our site and we examine the anchor tag, the hello world is printing our cookie on navigation link. So this is the first case where lax cookies are sent. The second case is when the user types in an address bar, open a new tab in the browser, type in the address bar. No matter what the site he is, what site he is currently in, if he goes to the address bar and type the hello.com check cookie, the cookies will be sent on lax. So address bar typing. So if I go back to the browser and from evil.com or whatever site you are in, you are typing the URL of hello.com check cookie, you see the cookie is sent as well. So the lax is really good if you want that cookie to be sent when navigating from a third party. For example, if you have a promotion code, so you want to know which site directed to your site to give him some kind of promotion or discount. For example, if you have authentication cookies, they are sometimes set to lax if you want the user to be navigated from a third party or from the address bar and still be logged in. Features like remember me and such. So the same site lax is actually very popular. In fact, this is the default the default mode of the cookies for most of the browser. I would still recommend explicitly stating that your cookie is same site lax, because maybe some browser it's not the default behavior, and also there is a known vulnerability of a short period of time that the browser are updated with the same site lax where they're exposed, their clients are exposed. So set the same site as lax explicitly. And your cookie will be sent only on navigation links and address bar typing. And of course, if your request is originating from the same site, of course, if you're in hello.com, that cookie will be sent. So cookie with lax on foreign sites only when navigation links or address bar typing, but in your own site, it will be sent. It will be sent as regular cookies are sending in your own site. The last option that we need to explore is setting same site to strict. So setting sameSite to strict is similar to lax, only it will not be sent on navigation links. It also will not be sent on address bar typing. So this is basically only sent from your own site, from hello.com. If a request originated from hello.com, it will be sent. So sameSite only sends the cookie from hello.com in this example. So we explored the different options of sameSite. Basically, we saw there are three options for a sameSite. We have the sameSite set to none. In this case, this is what you will do if you want to set a third-party cookies that you want them to be sent from different sites, not only your site. You can set cookie to lax if you do want your cookie to only be sent from your site, but there are some exceptions for navigation links going from outside your site, and so lax is the mode for that, and strict is only requests that originate from your sites are going to be the cookies will be sent. There are two flags that relate to the cookie expiration. So a cookie might have a date or a time when it is valid, and when that time is passing, the browser will delete that cookie. And the cookie flags are called expires as well as max age. Those two flags basically do the same, determine until when our cookie is valid. So basically, how long should the browser keep this cookie after the expiration pass? The browser will delete this cookie. So, and with the max age, I find it a bit easier. You can specify from the time you're setting the cookie with milliseconds. That's the case in Express. In milliseconds, you set how long should the cookie last in milliseconds, while the expires takes a date. If you want to set your cookie to be valid until a certain date, so it accepts a date format. So in Express, you see the example here. You take the response, you call the cookie, and the third argument, you're passing the flag. And we see here an example of expires. And expires, I want to set a cookie which expires 1 week in the future. So I take the current date moment and add a week to the date and convert it to date. And this will set a cookie for a week from now, to be sent a week from now. Let's explore the max age since it's a bit easier. I can set a cookie. I can set the cookie max age. And I can set the cookie to be valid. You pass here milliseconds in Express, so I can pass here, I want the cookie to be valid for 1 second, for 1 minute, for 1 hour. So I'm setting the max age of my cookie. And if I go back to the browser and go to set our cookie, I'm sorry, we're setting the cookie in hello cookie.js, and I'm setting the cookie in hello cookie.js. So I should see that I have an expiration. A max age is now set for my cookie. It's important to note that some browsers have a default to create a cookie as a session cookie if you do not specify the max age or expires. So if you don't specify a time for your cookie, some browser default will be, hey, this cookie will be a session cookie. A session cookie means that when your user is closing the tab of your site or closing the browser, that cookie will be deleted as well. So bear in mind to specify the max age or expires if you do not want, if you want to avoid that, if you don't want a session cookie. So expires max age allows you to determine a time where your cookie will be sent. So up until now, we saw that our browser is sending a request, and in the response, the browser might get a set cookie header, which means to the browser it needs to store a cookie, or the browser runs some sort of JavaScript that uses the document API to set a cookie. When you set a cookie, either by JavaScript or with your server response, when you set a cookie, you can tell the browser when do you want that cookie to be sent. And those determined by a few attributes of the cookie as well as the flags we just covered. So just to summarize what we discussed so far, when does the browser actually send the cookie? So we saw that the browser gets a set cookie and then stores a cookie. The cookie has a domain. So it's either a domain or subdomain, where we recommend on setting the minimum domain. So if it's possible to set a cookie only for that domain, so set it only for this domain and not for the subdomains. And if you actually need it in the domain and subdomain, so you can set it for the domain and subdomains. So consider the domain to be the minimum domain you require the cookie to be sent. And we talked about the path also. You set the domain and then you set the path of the cookie. So the prefix of the path where the cookie will be sent. So again, consider to minimize the amount of cookies you sent by limiting the path. So for example, if you have authentication cookies, only send them to the path of the authenticated requests, for example. Remember that if you're saving the browser from sending a cookie, you're actually making the networking faster, because the cookie might be there could accumulate to a lot of cookies and data. So if you're limiting your cookies, it will save you request response time. So the paths should be limited as well if possible. We saw that you have a connection secure flag. So I recommend most of your cookies should be in a connection with secure turned to on. This means only those cookies will only be sent on a secure HTTPS connection. We saw that cookies have expiration. So set an expiration for your cookies. For example, if you have authentication cookies, limit them so they will be so you can actually refresh them and not keep them too long in the browser for better security. And in general, decide for each cookie what is the expiration date of that cookie. We saw that that the same site with the same site, you can determine if your cookie will be sent from different domains. So the same site to none will make your cookie what we call third-party cookies. Those are cookies that are sent from third-party sites. You can have same site to lax if you want your cookies to only be sent from your domain or from navigation links or navigation links on where the user types in the address bar. You can set the same site to strict. Strict, if you want, are good, for example, for banks that do not want when the user closes the session that the cookie will be remembered, to protect more against CSRF attack. So the browser determines based on those 5 criteria if it needs to send the cookie or not. So whenever you're setting a cookie, try to consider those 5 points and try to really think what is the domain, what is the path, secure, what is the same site, and try to make your cookie as optimized as possible for your use case. When we talked before about what cookies are used for, we also mentioned that cookies are used to persist authentication. We call them authentication cookies. With authentication cookies, we can persist authentication. This means when the user logs into our app, we can store a cookie in the user browser, and using that cookie, we know that the user already logged in, and we don't have to make the user resubmit the login. This makes the user log in only once, and then he can transition throughout our application, and we will know that the user already logged in and who is the user. So those we call authentication cookies, but authentication cookies have to be secure. So when you place authentication cookies, there are a few rules that you have to keep in mind. So open your application, examine your authentication cookies, your session cookies, your JWT cookie or whatnot, and make sure that you follow the following rules, that those cookies follow the following rules. And those rules are, remember we talked about the secure flag? Authentication cookie secure flag has to be turned on. When you place the secure flag turned on, it will verify that the authentication cookies will only be sent on a secure connection. This means no third-party sniffer can examine the request and grab the authentication cookies. They're only sent on a secure connection. So this is the first rule. Secure flag has to be turned on. The second rule is your cookie HTTP only flag should be set to true. This is also very important. So the HTTP only, just a reminder, we talked about this flag. This flag will make a cookie not be visible to client JavaScript. This means that the document API in JavaScript won't be able to read the authentication cookies. And the reason why it's important for authentication cookies to turn on HTTP only, that this makes your app less vulnerable to cross-site scripting attack. Cross-site scripting attack is probably the most popular attack there is in the web, where an evil user try to place a snippet of his JavaScript code in your site by either posting or uploading an image or submitting a link. Or there's a lot of ways, creative ways where a hacker can try to place JavaScript code in your app, and we'll have a full lesson about cross-site scripting and how to prevent them. You set the HTTP only you set it to true. This means that if someone does manage to place malicious JavaScript in your site, cross-site scripting, your app is vulnerable to cross-site scripting. That JavaScript, that foreign JavaScript, cannot use the document API to grab the authentication cookies. So this will also prevent the hacker to grab your user authentication cookies. So HTTP only should be set to true, and client JavaScript should not be able to access your authentication cookies. Cookie sameSite should be set to either strict or lax. So if you want the user to always log out, to automatically log out when he closed the session, maybe if you're creating a bank application or something very secure, you can set your authentication cookie to strict. This means when the user closes, type a URL in the browser, follow a link, the authentication cookie will not be sent. But sometimes we want the user to actually be logged in after he returns to our site. So usually we set the authentication cookie to lax. If you want the user to return tomorrow, type the URL of your site and log in automatically instead of having to log in whenever he opens his browser or a tab. So either set it to strict or lax, but definitely don't set the authentication cookie sameSite to none. You don't want that cookie to be sent when a request is from another domain. You don't want the authentication cookie to be sent, and this is actually helps you against CSRF attack. It's not completely protects you, but it protects a lot of cases of CSRF attack, and we'll talk about CSRF attack after we talk about the authentication cookies. So make sure your sameSite is either strict or lax. And remember, it's not 100%, if you set strict or lax, it's not 100% bulletproof against CSRF attack. There are still ways which we will talk about soon, but it does prevent a lot of them. So sameSite need to be set to strict or lax. So make sure that your authentication cookie is, a malicious user cannot guess the cookie. He cannot guess the session ID. So the session ID, you should use a strong secret to protect your session ID. We'll talk about session in another lesson. If you're creating JW, make sure that your session that you have set an expiration for your session. If you're using JWT, for example, set expiration for your JWT, as well as set expiration for your authentication cookie. If you do have some sort of remember me mechanism and you want to be able to not delete, not expire the token, so make sure that you refresh the token. So you still have expiration on the token, but you have some kind of API where the user can send a request to the server and get a new cookie. So in any way, you should make sure that your authentication cookies has expiration and they're hard to guess the secret that they are hiding. So authentication cookies secure, HTTP only, sameSite strict or lax, and some sort of expiration for those cookies. And popular authentication cookies you probably are already aware of, that session. And we have a lesson and a link to the lesson about session. So session are storing user information on your server, but the server needs to identify the request, so is placing a session ID in the cookie. Usually in the cookies, the session ID is placed in the cookies. So storing session ID considered as authentication cookie. Make sure your session ID follow the rules that we talk about. This is a popular authentication mechanism that after the user logs in, I create a session for that user and store the session ID in the client browser. We also popular authentication mechanism is storing in a cookie a secret token, where the popular token mechanism will be JWT cookie. Now, I've seen a lot of articles about a lot of tutorials about JWT, placing JWT secret token inside local storage, for example. Bear in mind that this kind of mechanism, storing JWT in local storage, for example, and not in the cookie, will make your site more vulnerable to cross-site scripting, because it's your secret token will be accessed from JavaScript. Okay, remember, we set the httpOnly to true to prevent cross-site scripting. So make sure that your JWT, it's better to place your JWT token inside authentication cookie. It's more secure in terms of cross-site scripting, and this will make your JWT as secure as a session ID if you do it. Basically, they follow the same principle of storing in the cookie the secret token to identify the user. Make sure that JWT cookie has an expiration as well. What we'll do now is we'll write a code, and we'll try to place an authentication cookie just to make sure that you understand all the rules of authentication cookies and what you should bear in mind. So we'll do an exercise where we create a JWT authentication cookie. So let's go back to our IDE, where we are going to create our JWT login application. So this will be a simplistic version just to emphasize the important things about JWT. I'm not going to use recommended packages like Passport. Usually you combine JWT authentication with Passport JWT package. I'll bring the links for the packages below just to make sure that in the real world you use those packages, but we will make a simplistic example just to focus on the most important points about JWT. So in our ID, in our project, I'm going to create a clean slate, open a new directory. I'm going to name that directory JWT, and in the JWT folder, I'm going to create a new Express server. Now we already have Check Playground, which creates an Express basic application, basic server running on port 3000. So let's just grab the Check Playground and copy paste it in JWT and rename this file login app. We now have our basic skeleton of a login app. We can run this app by double clicking open, make sure the file is open, go to run and debug, and click run and debug. This should run, and if everything is working, we should see when we get the root path, we should see hello world. So let's go back to our browser and go to the root, and we see hello world is running. We should be able to also place a breakpoint. So let's reload, and we can now run and debug our application. Now we're going to create in this application, we're going to create three routes. So we are going to do this. We are going to go and run app route, create a route for login, and create for the login a get and a post. So these will be our basic login routes. So the get will send a login form, and the post will verify the login credentials and create a JWT token. And we're also going to create another route, which is only for authenticated user. The route will be authenticated. So this will be the basic routes we are going to create. Well, let's create the middleware function, request response, and send in everyone some sort of text just to see all the routes are working before starting to work on our login form. So in the authenticated route, I'm going to send hello authenticated. We'll replace that later on just to see that the route is working. So this is the authenticated route for now. We're going to create get for the login, and again we're getting here a request and response, and we're going to response with the send. Here we place the login form, and we also have a post request where we'll get the request response here as well, and here we will send. Here we will create a JWT token, and in here only users with valid JWT will be authenticated. Great, so this is the basic route we're going to create in this app. Usually this section, the authenticating the user, usually is done using, I recommend using Passport, but we'll have a different lesson about authentication where we will mention how Passport is working, but this is not our focus. Our focus is more on this section where we're creating a JWT and where we are placing that JWT token inside an authentication cookie. Now let's just verify that everything is running. So I'll reload my app. I now should have in my app login. Here we place the login form and we have an authenticated only user with valid JWT will be authenticated. So our routing is working. We will now focus on the get, where we will place login form. Now you can authenticate the user in different ways. There's a lot of ways to authenticate the user. So JWT is created after the authentication. So you authenticate the user. Of course, JWT is also a way to authenticate, but usually how you work with JWT is you authenticate the user in some way, either by typing his email or password or clicking a login with Facebook, login with GitHub, login with LinkedIn or whatnot. Whatever authentication mechanism you have, check out Passport. Usually Passport has an easy to use middleware for that authentication way. So usually JWT is combined with a form of other form of authentication. So you first authenticate the user with another form. In our example, it will be with a username and email. And then after the user is authenticated, you create the JWT and place it in a cookie. This is usually how JWT works. So we will now start and create our the way we authenticate the user for the first time using a login form where he types his where he types his username and password. Okay, let's create our login form. Now our login form will be a simple HTML file displaying a login. So I'm going to create in JWT folder, I'm going to create a login.html. Now, I'm not going to use any templating language, although it is recommended to use Pug or Mustache for your templating. I'm just simply going to return a simple HTML of a login form. So I'll do, HTML sample. This HTML sample will simply display login form. So let's display the header. And let's display a form, and our form will have an input where the user type is email. So the input is of type email, and the name of the field will be email. And let's place it in a div with placeholder email. And we'll create another input for the user to enter his password. So the input type will be password, and the name of the field will be password, and the placeholder will be John Doe. And we'll have another button to submit the form. So I'll place a button of type submit, and we'll name that button login. So a simple HTML for our login form. No template is used, simple HTML. What I will do in the form tag, I will place in a method of post, send a post request, and I'll place also an action to the same URL. Remember, this HTML is displayed in the URL get login. So what I'm doing is I'm taking the same URL get login. I might as well do like this. I can do like this as well, and I'm sending a post request to the login URL. This means it will get to this URL, and it will get to this middleware. And this middleware, what it will do, it will take the email, will take the password which we are getting in the body of the body of the request, and we would then usually you would take it and compare it to a database, but we will do something much simpler than that. We'll simply approve if the email is something hard-coded. Usually you'll take the password, you use bcrypt to encrypt you will use a library called bcrypt to encrypt the library, because you usually don't want to save the actual password in the database, and then you'll take the encrypted password and compare it to an encrypted password you have in the database. But in our case, we are focusing on the actual authentication cookie. So the actual login process is not that important for this lesson. So we'll simply take those fields and approve if they're hard-coded equal to some value. So this is the basic form. What we'll do, it's in the get, we're going to send file, and we're going to do call resolve. And you need to add an import for resolve in the path, and we're going to resolve in this route with JWT and login.html. Okay, so it will send the login HTML file. Now let's try and check that everything is working and try to access this login path. So I'll reload my server, go back to my browser and type login, and we see our login HTML. Great. So now what we will do now is try to implement the post after the login is sent. This middleware is called, and then we need to deal with the authentication cookie, JWT, authenticating the user, and so forth. So let's try and create the actual logging of authenticating the user. Great. So to implement the logic of the login form, we will need to grab the what the user typed in the form fields, right? So we usually grab those in Express from request.body. So from request.body, we want to and request.body, what we will get in request.body is an object, and the object will contain keys according to the form. So remember that in the form, our first input for entering the email is named email. So according to the name field in the inputs, name, email, name, password, you get in the request body an object with the keys set to the name of the field. So we have email, and we have the key, the name, password. So we'll get the password and what the user typed in the password. And we will get this object in the request.body field. So we can grab from the request.body the email and password. But Express is very minimalistic in nature and won't do it automatically. So Express doesn't place the body property automatically in the request. You need to actually set up Express and tell Express, and we're telling Express by using middleware, you need to tell Express that you want him to arrange the body of the request in the request body property. And we do this by grabbing a middleware called URL encoded. There is URL encoded and there is JSON. They both do the same. They arrange the request.body, but they both support different type of how the request body is arranged. So sometimes if you're just placing a form, then the way it's the request body is going to be arranged like URL encoded, like the field will be separated like in the URL query params. And if you place JSON, you can send also the request body in the format of a JSON. But since we're using a regular form, we can just use this middleware, URL encoded. So we'll take the Express app and we'll use the URL encoded middleware. What this will do, it will populate the email and password field, and we can verify that we're getting the email and password field by placing a breakpoint. Let's restart our server and go back to the browser. Type the email that we set. Type just an email. Doesn't have to be anything special. Hello world. And some kind of password. I type 128 and then go to login, and let's see if we're getting the email and password. The email is hello@world.com and the password is 128, what I typed in the form field. So this is a good start. We're getting what the user is typing in the form in our request body. And what we'll do now is we'll do a simple hard-coded comparison. So we will say if the email is equal to johndoe@academies.com and the password is equal to 128. Then the user is logged in. Now, this is not usually the case. I think in most of the cases, the users are registered and saved in the database. So you're saving in the database. You have like a table called maybe users. And in the user, you have maybe fields, email, and a password. Now in the password field, it's highly recommended not to save the actual password of the user. Rather, you usually will use a library called bcrypt to encrypt the password of the user and save the encrypted value of the password. Encrypt in a one way, so it could not be decrypted, not even by you, and not even by if someone managed to somehow grab your users from your database. So you're using bcrypt to encrypt the password. So usually what you'll do is you do a database find by the email you're getting, and then you'll bcrypt the password you're getting and comparing the two encrypted passwords. So this is the general way we do it. Since it's not our focus in this lesson, I'm just going to hard code it. If the email equals to something and password equals to something, then I'm going to create a cookie. The cookie is called JWT, and we'll place a JWT, create an authentication cookie. And then we'll send you are now logged in. And if the user is not logged in, so I'm simply going to send a status of 403, and I'm going to send bad credentials, invalid credentials. So this is our very basic login logic, and we'll soon create our authentication cookie properly. But for now, let's see that everything is indeed working properly. So let's restart our server and go even line by line. Let's go back and type in. Let's open again the login. Type the John Doe, the email we set here as our email, and type the 128 password. Great, we stopped at the breakpoint. We are grabbing the email and password. We're getting in the hard-coded where we compare the comparison pass, and we just created a cookie. We go back to, let's see if the cookie is created. We see you are now logged in. We can see the application, and we have our cookie created. Now, it's not the cookie. It's not an authentication cookie that we want. It's just a simple cookie. And we also didn't create the JWT token. So let's try to do it properly. So let's try to create the authentication cookie with secure, sameSite, httpOnly. What we said, this authentication cookie needs to be included. So let's place the flags that authentication cookie needs, and also create the JWT token that will be saved in that cookie. To create the JSON Web Token, we will use a npm installed package called JSON Web Token. Open your browser, type JSON Web Token npm, and you will see this is the first link that pops up. You'll need to install this with npm. So npm install JSON Web Token. Let's copy this. Let's go back to our code, open the terminal, paste the npm install command, and you can read the docs how exactly it works. I see the usage is to create a JWT token. You call the sign method in the library. You pass a payload, a secret, and a callback. So I don't remember if it's. I think it's also returns. No, okay. I thought it might return also a promise, and I don't recall. We can do npm install -t types to see the TypeScript declaration, JSON Web Token, just to see exactly what the sign is. So import sign from JSON Web Token, and the sign, we see here the declaration. After we installed the types, we can see the TypeScript declaration. We see that the sign returns a string, but the sign also returns a void, and the sign returns a void. Maybe we have a sign that also returns a promise. Sometimes those libraries not only returns a callback, they also return the same API that returns a promise. I see that this is not the case. Sign will, you need to pass a callback. But what you can do, if you do enjoy working with promises like I do, you can import from util a function called promisify. Now promisify, what it's going to do, it's going to convert a callback, since Node has a similar error first callback pattern. So what promisify is doing is you pass it a function like sign, and it will convert the sign to return a promise instead of getting callback, like here. We have also, you have also a sign that returns synchronously if you don't pass a callback, but I don't like that. You shouldn't use stuff like that synchronously to starve the main thread. We're not going to use it. Simply we use the callback way. We're just going to convert it to promise. So let's go back to our login, use the sign. So I'll create a JWT. First I'll take the sign and call promisify on the sign. This will return sign promise, the same sign that we that to create JWT, but returns a promise. And now I can do await to the sign promise. Of course, if you use await, make sure that your middleware function is an async function. So await sign promise. Now, when you sign, you need to create a JWT token. The JWT token stores a payload. So just a reminder of the format of JWT. I think it's jwt.io. So you have here the format of JWT. It's basically it has 3 sections. One section marked as red specifies the algorithm and the type. The purple is specify the payload that you pass. Everything is base 64 encoded, and the last one is it's an encrypted part that your server reads that contains the header part, the payload part, and a secret. And only your server can decrypt the third part. So this is basically the format of JSON Web Token. So you need to pass the payload. Now, usually what you do with the payload is you start with the minimal amount of data that your JWT needs. In a lot of cases, it will simply be your user primary key for the database. That would be enough. You don't have to store a lot of data in the payload. Make sure that be aware that if you store a lot of data in the payload, then your JSON Web Token will be longer, which means more data is saved in the cookie, which means the networking will be heavier. So as long as you add to the payload here, you'll see the token will be larger. Hello world. Let's say specify here hello world, and specify a few more keys. And let's do with each key that I add. Oh, sorry, what did I do wrong? You should delete this. With each key that I have, my JWT token, my JSON Web Token will be longer. So start with the minimum amount. Usually the primary key from your user table might be enough. Start with the minimum, and then if something happens and you need to store more, but start with the minimum amount that you need to store in the JWT token. In our case, our payload will only consist of the user email. So we'll place an email. You also need to pass a secret. So make sure that the secret is not something simple. It's not you have one secret that returns in many cases. Just generate a strong password, not like I'm doing now. So I'm placing make this a strong password. Obviously, don't use words. Use some kind of password generator, perhaps keychain. Or something else. So this will create your token. And let's verify, and we'll pass the token here. Let's just verify that we managing to create the token. So we'll place a breakpoint here, and we're going to restart our server. And let's go back to our login. Something is not working properly. Okay, so something broke. Name export sign not found. Okay, so something with my import. So let's import JWT and call JWT sign here. And let's restart the server. So our server is now running. So you shouldn't import sign directly. You should import JWT and then the sign. That was my mistake. Let's go to the login again. So our email we said was johndoeacademies.com, and password is 1 to 8. So let's type here and type the password. Okay, so it went to, we're turning the JWT sign from a callback to a promise. We are creating our token. So our token is created, and we can try also to take this token, and we can try to place this token here just to see that everything is working. I can place the token here. I can place the secret here. Our secret is make this strong password. I can place the secret here, and I can verify that my payload is correct and everything is should be similar to what I have. No, it's a bit different. I'm not sure what. Perhaps my header is different, so you can verify at least the payload section is okay, that you have the email, because probably my header is a bit different. This is why we have a bit of deltas between this and my JWT token. But we managed to create the token, and now we're creating a cookie with the token. Still, we didn't make our cookie secure. So the authentication cookie has some flags to be needed to be turned on. So let's turn our cookie to be an authentication secured cookie. Okay, turning our cookie, our JWT cookie, to be an authentication secure cookie is really simple. All it needs is supplying the correct flags when you create the cookie. So a few things we need to remember when we create authentication cookies. We need to supply certain fields, certain flags. So the first flag we said, we have to set secure to true. This means that if our app is not in an HTTPS secure connection with a valid certificate, the cookie won't be sent, which is perfect. We don't want authentication cookie to be exposed in an unsecure network. So we'll set the secure on true. Another thing that we'll need to set is HTTP only set to true as well. So our HTTP only will be set to true, which means that if the cookie, the authentication cookie, will not be exposed from JavaScript, so you will not be able to access them from the document.cookie API. So now we can read the JWT from document cookie, but once we set that flag and restart our server, we will see the document cookie, the JWT is not exposed, which is perfect, because if somehow a hacker manages to place and cross-site scripting JavaScript in our site, which has different ways to do that, he can actually read the authentication cookie. So it's really important that you say, okay, even if my site is vulnerable to cross-site scripting, which is really bad enough, and you should avoid at all costs. We'll have a lesson about cross-site scripting and best ways to avoid it. So we have a lesson and a link to the lesson below. So even if you do have cross-site scripting, your authentication cookie is still protected from that hacker that managed to run the client JavaScript in your user while your user is visiting your site. So you kind of reduce the damage that cross-site scripting is doing to your site by not exposing authentication cookie. So we set the HTTP only to be true as well. Now the same site, we need to set the same site to be, let's make it a bit more organized. So we need to set the same site to be, you control space and you'll see the option. As we said, the option is lax, none, and strict. You can either place lax here, which will be the case if you want your app to, if your user navigates from an external link and you want him to be navigated as a logged in user, or if the user opens a new session in the browser, type the URL of your site and you want him to jump and be already logged in, you want it to be lax, which is, I think in most of the web apps, maybe bank applications or some secure site will choose to place here strict, but in most cases the lax is the option you want here. The option you would want to avoid is placing none. None will expose you to someone sending an email to your user clicking the email, which goes to a different domain, different site of a hacker, and the hacker sends a request to your domain. It will send a cookie, what we call cross-site request forgery, which we'll talk in a minute. So you definitely don't want the same site to none. I'll set the same site set to lax. Another thing, you should set an expiration for your JWT. So when you create JWT, using the sign, you can also place options, and the options you can set is expires in. So you should set expiration to your JWT when you create your JWT, as well as set an expiration also to the cookie as well. And it kind of makes sense that those expiration will be pretty much identical. So place an expiration to the JWT. Let's see how we do that. In a JWT sign, I can set an options, and the options get an expires, which is a number expressed in seconds, or a string describing the time span. So you can set expires in, let's say, 1 hour. So let's set our sign, which gets an option. The option we're getting, we need to supply it after the secret or private key. So after this, we supply an option. We can set expires. What is that option? JWT sign options, and is an object with expires in. So we're gonna set expires in and it's expressed in seconds. So 1 minute, let's say my JWT is valid for 1 hour. And I can set also that the cookie expires is its date. Let's set max age. So max age here, and if I'm not mistaken, the max age is in milliseconds. So you can verify this with using the cookie parser. So typing express cookie, let's say max age. So the max age is 24 hours, so it's in milliseconds we see here. So 1 second, 60 seconds, a minute, an hour, and 24 hours. So this is in milliseconds. So we have 1 second, and we have 1 minute, and we have 1 hour. So I'm setting my cookie and my JWT to have similar expiration here. This is also important. Another thing that you can set is in your cookie flags is you can set a path. Where is my autocomplete's gone? Is it cookie options? Sorry. You have the domain that we want to limit to the same domain, and we have also path. So max age we specify httpOnly, and we'll specify path as well. So let's go back to our code, and the path will only want to send the authentication cookie on path that actually needs that cookie. So might be that some of your paths are open to the public and do not need the user to log in, but all our paths in our app that actually need the user to be signed in start with authenticated. So what we'll do is we will set the path to be authenticated. So do not send the authentication cookie in the case where the path of the request does not start with authenticate. So if the path starts with authenticated, it will send this cookie, and that's it. We pretty much have now on the flags we need for our authentication cookie. So let's save, let's restart our server, and let's log in again just to verify that everything is working. So I'll go back to my app. I'll go to the login, place my user and my password, and my app stopped, and I created a token with an expiration and a cookie with authentication flags. And now we can examine that everything is working. It's very important that you know how to examine your cookies. So make sure that if you have an app, you're examining your token, and you make sure that you examine your cookies, and you make sure that everything that's, well, we need to clear because we had a cookie. Maybe we'll refresh this. No, let's clear this again because we had a cookie before. So I'll do login again. Okay, this time I'm going to run it quickly, and we will now. Okay, so I'm not seeing the cookie, and the reason I'm not seeing the cookie is because it's only in the authenticated path. So if I'll go to authenticated, I should see the cookie with all the secure flags set. So make sure you open your app, examine your authentication cookie, and making sure that all the right flags are turned on your authentication cookies. Now that we set our authentication cookie, now it's time to deal with the third path that only the authenticated users can access this path. And basically, when you do JWT authentication, what you basically do is you grab the JWT token, we'll grab it from our JWT cookie, and then you are trying to decrypt that token that you got. So you are trying to grab the third part of the JWT token, the encrypted part, and you are trying to decrypt it using the secret that we provided. So if you use the same secret, then you manage to decrypt the server will manage to decrypt the encrypted part and grab the payload. Remember that the payload is encrypted there. So it will be able to grab the payload, and then using the payload data, we can get the user from the database. So we're usually getting a primary key, so get the user from the database and move on with the rest of the page after we authenticated the user. And basically this part, you usually combine passport and passport package called passport JWT, and this is basically what this package will do. It will authenticate the JWT token while decrypting the encrypted section and placing the payload as an object on the request.user. And we'll have a lesson about passport authentication, and we'll include part about JWT authentication using passport, but not in this lesson. So basically, usually you will want to use passport for decrypting the JWT token. So basically, we'll take the JWT from JSON Web Token, and other than the sign method that we have, we probably also have a decrypt. I think it returns token. I think decode. You place the token. Yeah, it's not, I don't think it's verify asynchronously verifies given a token using a secret or public key to get a decoded token. And this returns JWT payload. Okay, so I think it's verify. So verify gets a callback. We'll do promissify as well. We place the JWT token. We place the secret, the same secret we used to sign the JWT, and some optional options, and then we can decrypt the JWT token. So let's go back to our login app and let's implement the authenticated route. So first thing, we need to grab the cookie, the JWT cookie that we placed. So we grab the cookie using request.cookies. From here, we can grab the JWT cookie. And again, Express, being a minimalistic framework, will not automatically parse the cookies and place them in an object in the request. To tell Express that we want clean access to our cookies, we'll need to import the cookie parser from a package we installed earlier, and then we need to app use the cookie parser. This will make sure that we can access the cookies, and from the cookies we can access using the name of the cookie that we provided, that JWT name. A little thing that I'll emphasize, the payload that you place on JWT, the payload when we signed that we placed the email, bear in mind that that payload is also exposed to the client. So the client can read the payload section. It's basically base 64 encoded, so we can grab the middle section and base 64 decoded to read the payload. So bear in mind that the payload is exposed to the client. So don't place any passwords or stuff like that, sensitive data. In general, the payload is usually minimalistic, like primary key or something of that sort. So bear in mind that it is exposed. Also bear in mind that it's usually better to sign not with a password or a strong password. I would usually prefer to choose public private key encryption like RS-256. So usually it's more secure, so I would recommend this instead of placing a string here. So we're grabbing the JWT. We're then doing, we'll take JWT.verify, and we'll do a promissify for this. And this will return us a verify function that returns a promise. And the verify function, so we'll take the verify function, and what we're placing in the verify function, we're placing the token we get the secret, optional options, and a callback. So we get the token, which is JWT. The secret, it has to be the same like the secret we used here. If you're using a public private key like I recommended, so it's you sign using the private key and you decode using the public key. So in here, we're just placing the string here, and this returns a promise, so we can place a wait only if we use a sync here. And then we should get from the verify, we will get back JWT payload or a string. So we should get the actual payload. And we'll examine the payload now. We'll place a breakpoint here. Let's console log the payload just to make sure that we are getting the payload that we encrypted. In our case, we should get a payload with a key of email equals to johndoeacademies.com. So let's place a breakpoint here. Let's restart our server. Let's go back to the browser and go to the authenticated path. So we should get the JWT cookies, and now we have a problem, and our problem going to debug console. Request is not defined. The reason request is not defined, that we named it underscore request. Let's change it to request. Let's run and debug again. Great. And let's go back and try to grab now the JWT. So we got the JWT cookie token. It's currently undefined for some reason. So let's grab and see the network that we're sending the authenticated. We sending in the request. We should send the cookie. So I see that we're not sending the cookie. We're not sending the cookie because we don't have a cookie. Okay, so let's log in again. So let's go to hello.com login. Okay, let's restart our server because it's crashed, and let's go back, login. Let's place our credentials. We should be logged in. So it pauses on the login breakpoint. We are now logged in. A cookie should be placed, and now we should be able to go to authenticated. So now we should be able to grab the JWT. Great, our JWT is now grabbed. We need to try returning the verify function using promesify to a promise, which fails as well. And why does the promesify or verify failed? JWT verify is undefined. JWT verify is undefined for some reason. Best way is try to debug it using our debugger. So let's go back. JWT. Oh, I named the cookie JWT, and the name of this is JWT. They clash. So this is my bug. I can alias the JWT as JWT token. Okay, so this will require us to do a few changes. We passed it a verified JWT token, and I think that should be. Sorry for the mistakes. Let's try again, crossing my finger that this time it will work. So running the authenticated again, grabbing the JWT, this time is JWT token, promesifying the verify function, going to the payload, and I'm getting an email of johndoeacademies.com. So great, we managed to open the payload, and now we'll continue on, and we can just usually you'll take the payload, you grab the primary key from the payload, go to the database, etc. We're gonna just send, just to see that everything is working, we're going to just send the payload .email. Okay, so and usually you also will verify, so various steps can fail. So you can verify that you get a JWT, verify that the actual verification of the token works, and if it doesn't work, maybe place something in try catch and send 403 forbidden. So I didn't do that, but I just wanted to decode the JWT and send it. But in general, you would check the various step and send the user 403 if something is failing. Usually, however, you would use passport JWT for this entire process that we did here. Okay, just to summarize this exercise, remember that the lesson does not focus on JWT, rather we focus on authentication cookies. So I did the authentication with JWT while doing it quick to focus on the authentication cookie. So I did stuff with the JWT that was not best practice, considered best practice in a secure, when thinking about security. So bear in mind the focus was the authentication cookie. So I just want to go quickly on JWT best practices. So just emphasizing quickly things that I should have done with my JWT. I didn't because we focus on the cookie itself. But if I would want to create a more secure JWT, I would focus on these points. First of all, store the JWT as authentication cookie. There is another popular way to transfer JWT, and a lot of times you transfer the JWT in a header called authorization. And then sometimes you use the bearer scheme, so authorization, bearer, and the token. So this is also a popular way to transfer the JWT token to the server. It has its advantages. For example, would be less sensitive to cores, but it has the disadvantage of the fact that you have to store the JWT somewhere in the client. So if you have cross-site scripting vulnerability in your site, your token would be more exposed to the hacker that created the cross-site scripting. So I usually recommend store the JWT as an authentication cookies. In my opinion, it's better. Also, we signed the JWT using a secret string. JWT supports asymmetric, more secure hashing. For example, RS-256, which is encryption using public-private key. So you encrypt using the private key and you verify using the public key. So it's more secure. Also, I recommend rotating the key. So once in a while, replace that key. Make sure that your JWT is short-lived. So you have an expiration on your JWT and expiration also on authentication cookies. So make sure your JWT expires, and we're talking about hours, don't give it a long period of time. When you give it a long period of time, you're more susceptible to brute force attack of the token. So make sure you have a short lifespan. You can do some sort of refresh mechanism, but make sure you have a short lifespan for your JWT and for your authentication cookies in general. Payload should be small. So make sure, be aware that as long as your token stores more data, your payload is bigger. Your JWT token will be bigger. And since we're storing it in a cookie, the networking will be heavier. So think about the minimum items you need to store in the payload, maybe primary keys usually, and do not overcrowd the payload with things you don't really need. So payload should be small. Bear in mind that the payload is exposed to the client. Do not put sensitive information like passwords in the payload. You have certain fields in the JWT to match expectation. So you can place issuer, audience, subject, and then you can verify in the client, you can verify that the issuer of the token is whomever you expect to issue the token. Your server can verify that the audience, the client that sent the request, match the audience. So you have certain fields that are meant for the server and the client to verify the expectation from the token they got. So in general, these are some of the best practices I would recommend when creating JWT token. Now that we know about authentication cookies, and we know that authentication cookies are also used they can be used for JWT, they can be used for session authentication, which is probably the most popular authentication in the web. So authentication cookies are used often to authenticate our user, to persist the authentication of the user. And now that we know about authentication cookies, let's learn about a common attack regarding that way of authentication. And that security attack is called CSRF, which is cross-site request forgery. Cross-site because if I have hello.com, which we just created for a JWT, so hello.com or Facebook, something that you're logged into, this is the origin site, and you're logging into this site, and that site creates some kind of authentication cookie. So for our example, hello.com creates a JWT authentication cookie. I think Facebook creates a session authentication, session ID authentication cookie. So the origin sites create authentication cookie. Now, cross-site means I convinced the user to visit my site, not Facebook or hello.com, but let's say evil.com, the hacker's site. Now, the cross-site, the evil.com, I convinced the user to go to evil.com. And from evil.com, I will send a request to Facebook or to hello.com. That's the request forgery that's we're talking about in the name. So I'm sending a request and I'm hoping that the authentication cookie will be sent as well. So this is cross-site request forgery. And basically hackers use this trick to make authenticated requests from their evil.com site. I make authenticated requests to the user Facebook, Gmail, or hello.com, his bank, or whatever. Because he already logged in, he has authentication cookie. So if I somehow manage to place him on my site, I can send requests to those to the places that he logged in. So I can send requests on behalf of an innocent user. So basically, it starts with remember that it all happens in the client, in the user browser. The hacker only creates a site and then convinces the user to go to that site. And the user goes to navigate to an evil site. We will call it in our demonstration. We will call that site evil.com. So we convince the user to send to navigate to evil.com, and from evil.com we will send requests to our hello.com, where we created a JWT authentication cookie. So basically from evil.com, a request will be sent to another site. In our example, it's hello.com, and we're taking advantage of the fact that the user already logged into hello.com. And then if I send a request from evil.com, the authentication cookie will be sent. And the best way is to demonstrate with some sort of exercise. So we'll do a cross-site request forgery exercise, which we will demonstrate this form of attack, and also how it's prevented. So but in the TLDR, it's a lot of those attacks are prevented if your authentication cookie has all the necessary authentication flags that we specified, but that's not enough. For some cases, it won't be enough. So I'll talk about more measures to prevent this kind of attack. But our authentication flags prevent a lot of those attacks, so bear that in mind. So in the following exercise, we will demonstrate a cross-site request forgery attack. What we will do, we will take our JWT example, hello.com, which we created authentication cookie with a JWT. And so we're waiting for the user to log in and authentication cookie to be placed in the user browser. Then we somehow convince the user to visit another site we'll create here, evil.com, and evil.com will send a request to hello.com, and we will notice that that request will send the authentication cookie, and by doing that, exploit vulnerability in hello.com. So hello.com will set an authentication cookie, and basically evil.com will send a request to hello.com to utilize that authentication cookie and create authenticated request on behalf of our user. Let's go back to our IDE and start implementing the CSRF exercise. So what we'll do is we'll jump on the previous example where we created a JWT authentication cookie, and we created it in a domain hello.com. And so we'll run that app again, but this time I'm going to open the terminal and I'm going to run using NodeMon, since we won't be using the debugger. That site is working, and I'll run it with not with Node, but this time I'll run it with NodeMon. What NodeMon is doing a watch on the files, so whenever the files change, it's going to reload our server. So we're going to activate NodeMon to activate our site, and our site will now run on port 3000. So if I go to hello.com login, this is the site we created before. Great. So now what I'll do, I'll create another site called evil.com. So I'll take the check playground that we created earlier at the beginning of the lesson and copy paste it in the JWT folder. And I'm going to rename this file. This will be the implementation of the evil app. This is the app that the cross-site request forgery, the hacker, is creating to send requests on behalf of the user. And the evil app, for now, will just place hello world, hello. This is the evil app. Now the evil app will not run on 3000 because the hello.com is running on 3000. It will run on 3001. So this is the evil.com for now. Let's run it by opening another terminal and doing npx nodemon, and this time running the file evil app mjs. So I'm running the file or port 3001. Well, it should say 3001 here. So I'm running the evil.com on port 3001. So if we go back to the browser and we open another tab and we go to evil.com, we should see, hello, this is the evil app. Great. So our two sites is working. So basically CSRF, we have one site, hello.com, which you can imagine like a bank or a Facebook account or something you're logged into. So you're logging into to this account, to that secret account. And now your user entered his credential, is now logged into his Facebook, bank, whatever, and then your user gets a mail. Let's say the mail says he's the son of an African princess and he just inherited a few $1 million. And your user, for some reason, believes that mail and clicks the link, and then he's being directed to a site with a URL of evil.com. If the mail didn't trigger his suspicious, I think the URL of evil.com should have triggered something, but our user is going to evil.com, and now what we will do in evil.com, we will send a request to hello.com. Now hello.com has the user is logged in, and in the authenticated path we have an authentication cookie, and evil.com did his research and created an account in hello.com and saw the authenticated path and saw maybe the authenticated path here is transferring money. So let's say the authenticated route, what it does, if the user is authenticated, then it's grabbing the, let's say it's grabbing the from the request query, it's grabbing let's say bank account. Okay, and then to this bank account we are sending, let's say we are sending $100 to this bank account from payload email. So the evil.com did his research and he saw that a URL called authenticated is transferring money by getting a query param bank account. It will send money to that bank account. So evil.com, what evil.com will try to do is send a request to authenticated. So our user that is logged in will transfer him $100 to his bank account. So what we'll do now is we'll try, after we manage to redirect the user to evil.com, we'll try to send a request from evil.com to hello.com, and basically what we're doing here is a CSRF attack, sending a request to hello.com to do something malicious to the user on his behalf from an authenticated request on his browser. So back to evil.com, what evil.com will do is send a simple HTML. So let's create in our JWT evil.html file, and we'll do an HTML sample, and we'll create a simple HTML here where we don't need a style sheet as well. We need something, the evil site has to have something to display to the innocent user. So you will let's say the site displays this is an innocent site. Okay, going back, opening the evil Express app, I am going to send in the root to send that evil.html file that we created. So I'm gonna do response send file, and I'm gonna place here resolve for JWT evil.html. Now, Nodemon will automatically restart evil.com. So let's go back to evil.com. Sorry, let's close this. Let's go back to evil.com, and let's see that this is an instance site is displayed. So great. So evil.com displays something for the user, and in my opinion, if you go to a site with URL evil.com, which specifically says this is an innocent site, I have a feeling this is not quite an innocent site, but the user sees this and he's convinced that this is an innocent site, and he proceeds in evil.com. Now, going back to evil.com, we will open the evil HTML file and we will add some JavaScript to it. So I'm going to add at the bottom of the HTML, I'm going to add a JavaScript script tag, and then I'm going to use fetch to send a request to https hello.com to the URL of authenticated. And I'm going to send evil.com the login app we are sending with a query param of a bank account. So I'm going to send the hacker bank account number, so the money will be transferred to his account. So let's say evil account. Now, when I'm doing a fetch, I will add a few options to my fetch. I will add credentials include, so the cookie will be sent as well. I am going to also send mode no cores to the request. This is a get request, which is the default, and let's see the result of this request. So let's go back to our browser. Let's open the developer tab so we can examine that request. We will also make sure that our network disable cache is triggered, so we will load the new HTML file. Now, I'm going to send the authenticated app, and I get a few problems with this request. I get a bad gateway to the authenticated get request. How so? Let's try to run this in our site. Bad gateway seemed to be an Nginx problem. And our hello login authenticated is not working. Okay, so for some reason our hello authenticated stopped working. So it crashed for some reason. So let's restart our nodemon. Okay, let's just examine that it's working. Do a login. You are now logged in, and let's go back to our site. We should be able to get the authenticated now. Okay, so we get an authenticated, and let's go back to the evil.com and try to resend the request. So I'm sending the request again. Now the network is still getting a 502, probably because the request is getting to hello.com and something is causing it to crash. JWT must be provided. And the reason that it's crashed is it sent a request. If we'll examine the request, the cookies are not sent here. And why is the cookies not sent from the evil.com? So our CSRF basically failed. And why did evil.com did not send the cookie? The reason is that when we defined our login app, we set the authentication cookie with sameSite set to lax, which means that that security flag prevented this specific CSRF attack. So let's try now, and maybe we'll do a mistake in our authentication cookie and forget to specify the same site as lax, and let's see what happens then. So let's try to change the same site from lax. We'll change it to none. Let's say you have a mistake and your authentication cookie for some reason is on same site none. We'll also do, so our server won't crash as often as before, we'll do a try catch of the entire transfer, authenticated transfer. And in the case where there is a catch error, we'll simply send the response status of 401 equal to send and just write an error that sending money failed. Okay, we'll have to launch the hello.com again since it crashed. Okay, so it's running now. Let's go back to see that hello.com authenticated is working. Great. So it's working, and now let's log in again. Since we have the old cookie, let's examine the cookie. So currently our cookie in hello.com has a JWT, and you see the flag same site as lax. Let's delete this cookie and go back to login. Create another cookie that this time should be with same site. Okay, so let's go to authenticated, and the same site should be none. Great. Now let's go back to evil.com and let's try to send a request again. So I'm sending the request. This time I see that the request actually got a 200 okay. And the response is we are sending $100 to this evil account from johndoeacademies.com. So we saw that we managed, this is a successful CSRF, and by directing the user to a site, evil.com, and the user is not even aware that that request is sent. He's just directed to a malicious site with the email that we mentioned, or there's 1,000 different ways where a hacker can try to transfer users to his site, and the user wasn't even aware, but this site sent a request guessing that this user is authenticated to hello.com, sending a request, and then that request transferred $100 to his account. So this is an example of a successful CSRF attack. We noticed that when we set the same site to lax, so when we had the JWT cookie or authentication cookie was set the same we had the same site set to lax, it prevented the CSRF attack we created earlier. So the question is, does same site flag solve every CSRF attack? Can we just set the authentication cookie with the right security flags and then feel safe about CSRF? And the answer is that it does reduce, protect you against almost all CSRF attack and reduce a lot of the CSRF cases that you were exposed to. But you should be aware that it does not cover all the cases. There are some exceptions, some edge cases that you need to be aware that you still have CSRF vulnerability even though your same site is set to lax. So let's specify those edge cases. So older browser does not support same site. So we usually don't have that problem on modern web application. So a modern web application, we do expect certain version of a browser to enter, and in that case you need to be aware that which versions of browser you want to support, and if a user with an older browser enters your site, make sure to warn him and notify him that your web application does not support his browser version. So older browser do not support the same site. Just make sure to notify the user if he enters your site with an older browser. So older browser does not support same site, and in that case the lax flag won't protect you against CSRF. Get request can still be abused. Remember that if you set your same site to lax, this means that the cookie will be sent if you navigate the user. So instead of doing the request like we did using fetch, if your same site is set to lax, you can simply redirect the user. The evil site can redirect the user to the URL, to the exposed URL, and then it will send the cookie even on lax. This is why it's very important that you do not mutate your state on GET request. You do not insert to the database, delete or update the database. You do not do things that change the state of a user on GET request. In REST, we know GET requests are used to read data. They do not use to mutate the state. But be aware that on GraphQL, Apollo server by default allows to send all the query, all the mutation using GET. You do a GET, you append a query param. If I'm not mistaken, the query param name is query. And then you can execute mutation with a GET request. This is the default behavior to leverage caching in GraphQL. So make sure that you disable GET request on your mutation queries. You have to specifically do that. This is not the default behavior. So make sure you do that. Otherwise, you are exposed in GraphQL in Apollo server to CSRF attack. So GET request can still be abused, like we just saw, by referencing the user to the site. So as long as you notify older browser, you notify with an error that you do not support their old browser, and do not let them proceed in your app. As long as you do not mutate your state in GET request, you do not insert, update, delete in GET request, you are protected against CSRF attack. If you do want to support older browser, if you do have a web app that does need to support older browser that does not have a same site, you can use a CSRF middleware. Be aware that the popular CSRF middleware was named CSURF and is now deprecated due to security warnings. And they will tell you the similar thing here. The NPM model is currently deprecated due to large influx of security vulnerability. This is largely unnecessary for modern single-page application-based applications. So those kind of middlewares are no longer needed in modern application. But if you are letting your user enter with an older browser, you do need to include some sort of middleware. And those middleware work pretty simple. They usually create a CSRF token, usually send that token using a cookie. Or session, they're sending this cookie, and then they are forcing the protected routes to send CSRF cookie, and they compare it with the cookie. So they force the authenticated route. They will force a cookie to be sent. So to send a request or authenticate it, they will have to send a CSRF query, a CSRF token that is generated, and then that middleware will compare it with the cookie. So this is how generally they are working. So in case you do want to support all the browsers, you do need some kind of middleware protection and create a CSRF token. So to summarize this lesson, we talked thoroughly about, I think, the important things that developers should know about cookies. And basically, cookies are using to persist. So either I persist authentication, I log in the user and then persisted authentication using authentication cookies. Either I'm saving a state. If the user buys something and I want to store it in a cookie, that is a shopping cart or whatever, I can save the state in the cookie. Bear in mind that saving the state in the cookie does make the networking heavier. So make sure that your cookies you only save in the cookies what needs to be saved. It's also used for tracking and analytics. So the browser saves the cookie and automatically sends the cookie on certain request. If the domain match, if the path match, if you have certain flags that match, then the browser automatically sends the cookie as a header. I do not recommend using third-party cookies. Safari and Firefox are now preventing by default third-party cookies. Chrome will soon join them. So bear in mind that if you are setting cookies on sameSite none on different domains, make sure to try to use a different solution, because third-party cookies are not by default on most other browsers will not be supported. Authentication cookies. Make sure that your authentication cookies, you have the secure, you have the same site, you have the httpOnly, you have expiration for those cookies. So make sure the authentication cookies follow the best practices we talked about today. That's it, folks. That's our lesson about cookie. Thank you very much for listening. Now that we know about cookies, we can learn about sessions. Sessions use cookies. So they use the cookies to save the session ID. So now that we know everything we need to know about cookies, we can learn about using sessions in Express. So join in the next lesson about sessions in Express.